So the proof, we don't need GR. It's got nothing to do with GR. We're going to do it either from the Aether or from Newton or from Galileo.
Okay.
Really simple. I mean, I'm not going to do it. I'm just going to explain it. And I leave it as an exercise for the reader, obviously.
Okay.
So when you look at Newton, so why does so what's so anyway, it's very simple. So Newton, when everybody looks at Newton in the solar system, they assume that the sun is a point mass, and all you need to do is assume the sun is a sphere. Done. And that's basically what happens in GR. In GR, they probably just feed in that the sun is a sphere. It's got nothing to do with relativity. There's no relativistic effects. It's too slow. So GR is garbage. SR is wrong, and I'm done. So any further questions?
Wow, that was pretty fast.
Yeah. If you have any questions, I'll gladly answer any question.
Not at the moment, no.
So yesterday, I still was compliant, but I came to the conclusion that SR is wrong. There's one case that I can that Einstein and I disagree, and I have a mechanical explanation. Einstein doesn't, so Einstein is wrong on SR. You cannot just transform coordinates. That's ridiculous. The universe is not a mathematical equation. The universe, I mean, it's a mechanism. You cannot. I mean, if I'm physically, there's an absolute frame of reference that is the ether. Relatively absolute frame of reference. That's the ether. And if I'm moving relative to the ether, then my clock is slower than somebody else who's not moving. And I cannot just pretend that I'm moving and he's not, or I'm stationary and he's moving. There's no such thing. My clock is ticking slow when I move through the ether. So anyway, so I came to the conclusion that SR is wrong. And then the last problem I had was the Mercury precession. So I'm assuming, I didn't go through the calculation. I'm just assuming that in GR they plug in the actual sun's radius or something. And that's why it affects Mercury, because for Mercury, the sun is a sphere, right? When you look at the sky, you look at Mercury, it's like it's very close. So you can't just say that for Mercury, the sun is a point mass. You have to actually consider the fact that it is a sphere. Wait a minute, isn't that a violation of Gauss's theorem? Gauss said there's no difference. Wait a minute. No, still a problem. Still a problem. According to Gauss, so the inverse square law comes out of Gauss's theorem that, well, if you know Gauss's theorem, you know. So why is why is it different if it's a sphere or a point mass? Why would it have any impact? Anyway, but
I have a meeting that just came up. I have to run.
All right. See you. Thank you. Bye.
But Totoro can help you. Bye.
Bye. So
With what?
What?
You're kind of breaking up, by the way, Mr. Slave. Your voice.
Really? Wait, Amber, am I broken up?
Not right now.
But before I was breaking up?
A little bit.
Oh, okay. Anyway, so Newton, when we calculate, stars, the solar system, and every planet, we assume the sun is a point mass. The question is there a difference between assuming the sun is a point mass and assuming the sun is a sphere? Does it impact Newton? So
at solar system scale, no.
What? But
At solar system scale, no.
wait. Okay, so Mercury is very close to the sun, and Mercury you can see
Hang
Mercury.
on, let me disconnect and reconnect.
Okay. All right. Can you hear me? 1, 2, 3, 4, 5.
It's still pretty heavily, it's like warbling and modulated coming from you.
Oh shoot. Let me leave and exit and come back. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is it any better?
It's still, I mean, it's readable at least, but yeah, it's still the same. Anyway, carry on.
I can hear you. I don't know.
Okay.
I don't know.
Anyway.
Maybe it's me. I don't know.
Anyway, so for Mercury, when you look at Mercury, I mean, we can see Mercury. It's a tiny dot when it eclipses the sun. It's eclipsed by the sun, so it's a dot moving across the sun. So I can only assume that from Mercury you can see the sun as a huge sphere. The question is, why would that impact the precession?
The sun will appear about 3 times bigger. Not as a huge disk, just 3 times bigger. So instead of 1/2 degree, it'd be about 1.5 degrees in the sky.
From Mercury, it's only 1.5 degrees?
Yes.
Okay.
Mercury is about 3 times closer to the sun than the Earth. So yeah, it's going to be 3 times bigger.
Mm-hmm. So the question is, why would that cause the precession? If I'm close to a sphere, is that different than if I orbit a sphere? Is it different than I orbit a point mass? Why would orbiting a sphere? Why would I care that it's a sphere? Let's say I'm very close to a sphere. According to Gauss's theorem, there's no difference, right? Newtonian gravity is, I mean, it's the inverse square law. The inverse square law is Gauss's theorem. You can derive Newtonian gravity assuming fluid dynamics from Gauss's theorem. Lenny Susskind does it in Intro to GR in his second lecture, I think. So, but he shows that from Gauss's theorem you get the inverse square law. What did Einstein plug into his GR equation about the sun?
To the window, to the wall. Till the sweat drips down my balls. Till all you bitches crawl. Till
Amber,
ski motherfucker. Yo, ski goddamn.
Amber, could you not do that? We're on somebody else's server. And like we're trying to have a conversation. So Toro, do you have some idea like why would, like, what did Einstein plug in?
I don't know the GR solution.
Yeah.
I can estimate that the reason for the precession of Mercury's orbit based on Newton's. So the problem, the precession of the perihelion of Mercury is not caused just by GR. Newton already predicted a part of it. The problem for Newton was that he didn't predict all of it.
Mm-hmm.
So there is a certain amount of precession. It is fairly small,
mm-hmm.
and Newton's equations predicted about, give or take, about 90 to 95% of it. But there was an anomalous remainder of the precession which was measurable,
Mm-hmm.
and which was not derivable from any Newtonian mechanics. And the solution there was GR. So if you want to talk about the 95%,
Mm-hmm.
it is caused by, as far as I know, the majority of it is caused by the presence of other solar system bodies. So things like Venus, Earth, and Jupiter are what's causing additional gravitational influences on Mercury, which is causing the precession of its orbit.
Mm-hmm.
That remaining little bit, that
Mm-hmm.
was the one where we needed general relativity to explain it.
Mm-hmm. Okay, so GR is just Newton with SR. Now SR.
No, 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 no. No, it isn't.
Okay.
GR is a superset of both special relativity and Newton,
Yeah.
so to speak. It's a more generalized description of gravitation,
Yeah. What
well,
what
among
is
other
there?
things.
But what is the what does GR, like, I know GR assumes the equivalence principle and SR my ether gives me SR. It gives me time dilation, length contraction, the rest of it. So that's not an issue. That's mechanical. My ether also gives me gravity, gravitational lensing, gravitational time dilation, and the rest of it. But what exactly does how exactly does GR create this extra precession? Like,
In general relativity,
yeah.
in gravitational fields, E and GR,
Hmm.
the paths that an object can take are not strictly in. If the field is strong enough, it will not be simply an ellipse. There is an additional spatial perturbation, which I don't know all the mathematical details behind it, but there's an additional spatial perturbation in the path, the geodesics, that are possible in the general relativity framework in a particular solution that is going to give you non-Newtonian orbits. And that is basically the precession. That basically is an additional deformation of the path of the geodesic, which is then manifested as the additional slight tug on the perihelion of Mercury. Another consequence of it is, for example, in black holes, the naive interpretation of black hole physics. If you just simply took Newton, there's a thing. Theoretically, if you just wanted to shoot a particle with mass at a certain speed, and if you theoretically could get to as close, arbitrarily close to the event horizon as you wanted to, as long as you didn't cross it, you should be able to orbit a black hole, right? That's Newtonian interpretation. Well, general relativity says that that's actually not possible. There is a certain minimum, something like 1.5 times the Schwarzschild radius, which is the lowest stable orbit, and within that, all orbits eventually quickly decay down into the black hole. That is a general relativistic effect due to the additional perturbation from gravity.
Where does
So there,
so it's gravitational waves, basically?
I don't know. No, it's not a gravitational wave. I think it's something to do with the space-time geometry that causes the internal paths within a gravitational field to be deflected by more than what Newton would predict.
I mean,
So it's causing
it's
causing a deviation from a simple ellipse.
Look, to deteriorate, to fall into a black hole, you need to lose energy. To fall from one stable orbit to fall to spiral in, you need to lose energy. So something has to take that energy. So
I don't know, maybe.
no, I mean, of course. I mean, if you, that's just geometry. So inverse square law gives you, at any orbit you can get, with any velocity you get a stable orbit. Any velocity gives you a stable orbit. Faster, faster, faster. The stable orbit is further.
By the way, your Newtonian interpretation of gravitational lensing is incorrect. It disagrees with experiment. Just FYI.
Wait, look, I can.
Mr. Slay?
Yeah?
Yes, our very same Mr. Slaves here.
Are you gonna explain to me how Newtonian predicts the precession of Mercury?
No, it's been we managed to debunk it. Look, gravitational.
What? No. We didn't manage to debug jack shit. Gamma, their Newtonian mechanics predicts almost all of the precession, but there's an anomalous remainder. That was the problem, basically.
I meant we managed to debunk my proof.
Your proof of what?
Never mind. Anyway, gravitational
lensing?
No, forget it. Gravitational lensing, I can easily explain with ether. That's not a problem.
You really can't. If you're going to be using Newton for that, you're going to get an incorrect result.
I'm not. I'm using Galileo or ether. Look.
Yeah, cool stuff.
Look, the point is, I'm able to predict the mechanism. Now, the unstable black hole orbit, I can predict with gravitational waves. I can.
Your mechanism, however, is not specified, so you don't have a rigorous definition of it. All you have is a bunch of word salad.
Anyway, look, I'm comfortable with gravitational lensing. I'm comfortable with what you just said about an unstable orbit close to a black hole. I can reproduce these things. However, precession, I'm still unable to reproduce precession. So that's why I'm curious, what exactly is causing the precession? So you explained to me the unstable orbit. That sounds like gravitational waves, because you have to lose energy in order to spiral into a black hole. There's no two ways about it, as far as I understand. And it's easy to lose it through gravitational waves. It's fine. But if we're using gravitational waves for Mercury, it's going to spiral in. So that's no good.
I'm not saying it's gravitational waves.
Yeah, I'm saying it's not gravitational waves. So we need another mechanism. So you're saying,
well, you should probably read the page that I linked there.
okay, let me see. Innermost stable circular. I agree with that. I told you I can reproduce it with the ether. That's not a problem.
Well, apparently you didn't even know about it, so keep reading, and then
we can
talk.
Is it about Mercury?
It is about the innermost stable circular orbits around a black hole.
Okay, I can reproduce that. I can reproduce it. It's fine.
So you say, and yet you don't know what it is. So that's kind of interesting.
It's fine. It's fine. It's fine. The question is, how can we reproduce the precession of Mercury? So the sphere. What about the sphere? The sphere doesn't do us any good. What about the fact that Mercury?
As you have not actually specified any mathematics behind your theory.
Okay, never mind. Just tell me.
I cannot work with it.
Okay, what about this? Is just we're just trying to create a precession through some Newtonian mechanism. So we know Newtonian.
I already told you.
We know Newtonian mechanics. Now let's try and come up with the ultimate precession. The precession. You said it's the rest of the planets. That's fine. What about the fact that Mercury is a sphere? Maybe that should give us. No.
That's very unlikely to be causing a lot of problems.
So the sun is
by far. If you have a look, there's actually a breakdown table per helium precession of Mercury. It gives you a breakdown table of the contributions. The gravitational tugs of the other solar system bodies is something like 90% of the effect.
Mm-hmm.
There's some tiny effect from the obliqueness of the sun, which is almost nothing.
Mm-hmm.
Then there's the general relativistic effect, which was the one that was the remainder.
Mm-hmm.
That was the thing that couldn't be accounted for using just Newton. And then there's a tiniest effect of frame dragging, which is the lens throwing effect, precession, if I understand it right. Yeah, lens throwing is frame dragging, which is also another GR effect, but that's, again, minuscule. By far, the largest contributions are gravitational tugs from other solar system bodies, and then gravitoelectric effects, the Schwarzschild like general relativistic effect.
Wait, electric?
It's called gravitoelectric effect.
Why is it electric?
I don't know. Read up on it. I only know it as the general relativistic effects, but this is, I haven't studied this in detail. I just know GR predicts that remaining, 10% of the effect, or less than 10% of the effect.
So it's some sort of magnetic effect, electric effect. You don't know where can I read about it? Like Wikipedia.
I don't know.
Mm-hmm.
Maybe I didn't send you the link, so go ahead and read up on this. Scroll down within that section. There's a table that breaks down the contributions.
The tests of GR?
Yep.
Let me see. Amount, gravitational tugs of other solar. Okay. Ablateness of the sun. Gravitoelectric effects. Schwarzschild like a general relativistic. Okay. Schwarzschild, I'm able to account for Schwarzschild using Newtonian mechanics. I don't need GR for Schwarzschild unless there's like, what is Schwarzschild like? What does that mean, Schwarzschild like?
Means you don't actually understand what the Schwarzschild metric actually talks about.
I'm able to derive Schwarzschild radius directly from Newton. So
I'm
what,
not talking about the Schwarzschild radius.
so what else is there?
Nah, perhaps you should read up on general relativity. It'll talk about that.
Yeah,
Solutions to general relativity. It's field equations. You'll very quickly come about the first solution that was proposed in 1919, I think, or 1918, by a guy named Karl Schwarzschild.
I know his solution. I can derive his radius directly from Newton.
Right,
So,
well, you don't actually understand what the solution is, so it's okay.
how am I
It's
able?
not Schwarzschild's radius is not the same thing as the Schwarzschild solution to Einstein's field equations.
Wait, at the end
Different things.
Wait, at the end he gives us the Schwarzschild radius. What else? What else do you want?
No.
What
The
else?
Schwarzschild metric is a solution to Einstein's field equation that talks about a specific shape of space-time. It does not say the Schwarzschild radius is just a particular case of the Schwarzschild metric at a certain distance from a certain mass, but the Schwarzschild metric is more general. That's why I tell you, read up on GR, learn. Then you won't be making these stupid Mickey Mouse mistakes.
Okay, what does Schwarzschild give us? What does he give us besides his radius? Is there some you're saying?
Read this page.
Which page? The one I'm looking through it. I mean, I see right away. Right away, I'm seeing Schwarzschild. Amber, you're hot micing. Can you mute yourself? Look, it's very significant. It's 43, so it's the second most significant. Why is it electric? Gravitoelectric? General relativity? Schwarzschild like, so it's not Schwarzschild, it's something like Schwarzschild? Let's look up gravitoelectromagnetism. Refers to a set of formal analogies between the equations of electromagnetism and relativistic gravitation, specifically between Maxwell's field equation approximation valid under certain conditions to the Einstein field equation for general relativity. Gravitomagnetism is a widely used term referring to specifically to the kinetic effects of gravity in analogy to the magnetic effects of moving electric charges. The most common version of GM is valid only far from isolated sources and for slowly moving test particles. The analogy equations differing only by some small factors were first published in 1893 before general relativity by Oliver Heaviside as a separate theory expanding Newton's laws of universal gravitation. Oh, so that's interesting. So Oliver Heaviside already corrected, so that's very interesting. So Heaviside gave us the Newtonian corrections.
He's one of the gods, as per Ken Wheeler.
Heaviside?
Yes.
Okay.
This approximate reformulation of gravitation is described by general relativity in the weak field limit. What is that?
Is Mr. Slave broken up for everybody or just for me?
Just you.
Fuck, stupid Discord.
No, you probably have a bad
'Cause
connection.
everybody else is okay, from what I can hear.
So you have a bad connection. Okay, what is
No,
the
everybody else's audio is fine. Concave, say something.
1, 2, 3, 4. Count to 10. The best thing is to count to 10.
No, that's it
Slowly.
for me.
Weak field approximation.
I'm gonna see the ether bounce off the atmosphere tonight, Mr. Slave.
The ether does not. Well, I mean, the ether
I was
is.
trying to make you happy, Mr. Slave. Just enjoy it, okay?
I'm happy. I mean, you cannot make me happy. I am happy.
I don't make you happy.
No, you cannot make me happy by lying to me. That you make me sad. Why would you lie to me? Anyway, in the theory of general relativity, linearized gravity is the application of perturbation theory to the metric tensor that describes the geometry of spacetime. As a consequence, linearized gravity.
My
But
fucking God. What the heck is going on?
the Schwarzschild metric. So
What's up?
What is
What's
weak?
up?
What is weak field approximation?
Mr. Slave, you have 99.99% of physics to learn of all of the discovered
Yeah.
physics.
Why do people always want to jump to the back of the book instead
Yeah.
of start at chapter 1?
That's right.
Because it's boring doing the simple stuff. Who wants to solve?
Let's unify all forces, guys. Why should I learn 10 fields of math first? Let's unify gravity with whatever. Else it's boring.
So nobody's going to answer my questions. We're back to making fun of me instead of just having a conversation. Wonderful. What else is new?
What's your question, Mr. Slave?
Come on, I'm talking to all of the people here. It's not a debate with a center.
What
My
is your
question-
goal? Hey, Mr. Slave, what's your goal in what's the end game here?
The end game is a redefinition of science. So I'm redefining science.
What?
I'm redefining science. My definition of science is that it must be mechanical.
What does that mean?
The universe must be mechanical. That's my assumption.
It means that he must be able to understand it, otherwise it's not science.
Exactly.
Isn't it mechanical?
Well, quantum mechanics
Well,
seems to be mechanical, but SR and GR don't seem to be mechanical.
Quantum mechanics is? Well, that's news to me, because
Yeah.
previously you were ranting very heavily against the Schrodinger equation
No, I'm very happy with Schrodinger.
and wave functions.
I'm very happy with the wave function.
Really now?
You're lying, Mr. Slave.
Because
Who told
previously
you?
you were having a massive problem trying to wrap your mind around the double slit experiment.
Look, I told you that I didn't look into the double slit experiment. I had a conversation with you. I know some rumors about it. I don't have the raw data. I don't have any data. I have just one video that you said that Veritasium said. I barely took a look at it. I need to look at it for now. What?
Paper that was given to you as well.
What?
A paper with a video demonstrating the effect.
Yeah, I mean, I didn't get there yet. I mean, I'm still, trying to figure things out. But for now, like the wave collapse, it's to me right now. It doesn't bother me too much. So I'm kind of happy.
You know,
with-
Mr. Slave, as you said, putting in your own words, lying makes me unhappy.
Yeah. So anyway, but also I'd rather not have meta conversation. So if you want to have a conversation, it's fine. I don't want to waste my time. So
That's a meta conversation.
So Brenda, you asked me what's the end game. So I told you
Yeah.
I'm redefining science. It must be mechanical. Quantum mechanics is I'm very happy with it. It's very mechanical. The little quantum mechanics that I understand, I'm very happy with it. I'm happy with Planck, Einstein, with all the experiments that I'm familiar with.
Are you happy with entanglement?
I heard people talk about entanglement, but I also heard
Oh dear. Uh-oh.
Brenda. You want to talk?
Spooky action at a distance coming up.
Look.
Oh yeah, in
So-
our debate on Friday, Brenda Whitsitt was saying that Einstein described gravity as spooky action at a distance.
Do you have a recording of that?
Yes. Wait, did you not hear his quote from that, Brenda?
Would you
said,
pretty please DM that a link to it if you could, please? Something I'll get around to it later.
Yeah, if you don't
Put
mind. Hold on,
put it
I've
in
got-
chat. Put it in chat. I want to hear that too.
Yeah, I don't have a clip to the particular part, but
Oh no,
he
I want to
also
listen to the
said
whole.
this.
Guys, do you know what's the final level of hell?
What?
It's these debate servers like this one.
You're right.
Forever.
Yeah. Oh my god.
Anyway, Brenda,
You should have
do
heard
you
the
want to
debate
talk?
last night. You should have heard the
Yeah,
debate
kind
last
of.
night between dogs are gods and a flat
Damn.
earther about whether hand washing is a form of technology and whether Indians can be godly.
Oh my
That was a
god.
great one.
Nice. I lost it. Damn.
Brenda, check out the clip I just posted.
So Gravity Probe B proved gravitomagnetism, which is something that's
Yes.
like frame dragging.
Yeah.
Yep.
So what happens there? How does that work? So
I have a thousand topics that you can say what is this and what happens there.
what do you mean?
Have you
There
guys
are
met?
about 10,000 topics more like this. And
Have you
worse.
guys mentioned Bell's inequalities to Mr. Slave yet?
Oh my god.
We have, and he says that he doesn't know anything about spin, and he needs it to be demonstrated by something other than quantum spin because he doesn't understand that.
I would like to listen to that because I know fuck all about that stuff. I mean I just don't understand it. I mean,
Wait,
Yeah,
can you
it's a certain
explain,
person,
Brenda?
so-
Brenda? Let's finish one thing at a time. So what is this frame dragging? What exactly happens in frame dragging?
well, my understanding is that it's related to satellites in orbit around Earth, sort of drag space-time along with them a little bit. And I don't understand how that happens because I do not know the physics well enough to explain that. I simply know what people have said.
So it's actually the rotation of the Earth. It's like a space-time Coriolis effect. A rotating mass energy density produces essentially like a Coriolis force in space, like a Coriolis effect in space-time.
Oh, but Oakley assures me Coriolis is just an illusion. So, haha, take that, Glover.
Yeah. Welcome to Flat Earth.
Also search about the CP violation and try to solve this because it's unsolved.
I know what CP violation is. It's a
Anyway,
symmetry violation. That's what it is, right?
Okay, so I'm trying
Did I
to
get-
I'm trying to understand frame dragging. So frame dragging is causing Mercury to precess. Is that it?
That is one of the contributing effects, as I showed you in that at the Wikipedia page.
Right, but they say it's 43 out of 474. It's like the second most by far.
No,
Wait,
lens
what?
stirring, that's the frame dragging, is approximately 0.002 arc seconds per century.
Wait, I see the sources of the precession. Number one is the tugs of other solar bodies. Number three is 43 units. That's gravito-electric effect, which is like, I think from what I see from the next Wikipedia, that's just the frame dragging. That's the gravity probe B. So that's that, and that we already said that that's not GR. That's actually from Heaviside. So Heaviside gave us gravito-electric effects. It's from Wikipedia. The analogy and equations differing only by some small factors were first published in 1893 before general relativity by Oliver Heaviside as a separate theory expanding Newton's law of universal gravitation. So it's not GR. Maybe it's incorporated into GR. I don't know.
Maybe you need to read up on it a little bit
I'm
more.
reading right now.
You-
I'm reading and we're talking. So the question is the gravito thing, is that explaining, so it looks like that is what we're looking for. That's the missing piece that Einstein solved. So somehow it's incorporated into GR, but Oliver Heaviside already gave it to us. Apparently. So I'm just trying to understand the mechanics. So frame dragging, that's like one of those things that I find a little bit challenging for my ether.
Just a
That's
little
the
bit.
that's the
little bit.
challenging part. Okay, you've got other parts that are much more challenging.
Like what?
Like for instance, your claim that you can explain gravitational lensing
Yeah, that's easy.
using Newton's equations.
Yeah, that's
yeah,
that's it. I can explain using ether.
Except yeah, sure. So you say you derive it from Newton?
Well, if you let me finish the sentence, so I can derive it either from ether or from Galileo or from Newton. It's your pick. Pick one.
Okay.
I
Well,
can
please.
explain I can explain gravitational lensing. I can. You
Why
want
not?
to hear the explanation?
Without
Yes,
GR.
yes, you want to hear it? It's when God sets his monocle down on the table.
There you go.
Yeah. Okay.
I'd like to see your derivation of the gravitational lensing effect there, Mr. Slave. Go ahead. Feel free to screen share and show us how you do it.
Okay.
I have to ask though, wouldn't ether as a medium make frame dragging?
Yeah.
Wouldn't that make that easier
Who's asking?
to
Maybe.
understand? Because it's a
is-
medium.
The problem is Mr. Slave here doesn't specify any dynamical equations for the ether, so we don't actually know what it does. It does whatever he needs it to at that moment, just by word salad, by the power
like
of word salad.
Something moving through a medium is going to cause some kind of wake in that medium. Like that's a thing that we know happens.
Then that's the answer.
So the
Okay.
fact that you think it makes it harder for ether means that ether follows nothing in physics.
So my ether is basically a fluid.
Yeah, that's the immediate issue.
What do you mean?
If something's going through the ether, then it would cause a drag. It would cause an effect like a wake.
Then I said, then that's the answer. Then that's the answer. I mean, I
But you said it doesn't happen. You said it makes it harder for ether for that to happen.
like my ether flows. My ether is not stationary. It flows into massive bodies. So it's like a river. It's like it's a fluid. It flows into the sun really fast. And the sun, you're saying that the sun's rotate, so it's the sun's rotation that's causing Mercury's precession? That's frame dragging. You're saying the sun's rotation
No.
is, but that's frame dragging. So what's causing Mercury's precession? So
A
Wikipedia.
lot of things.
What do you mean? I mean, I'm reading from Wikipedia. So Wikipedia,
I mean,
what?
how did I just come into this conversation and I understand more of it than you? How did I come into here? Like, it specifically says that the precession of Mercury is for multiple reasons. One very tiny one being the frame drag.
No.
Frame
So I'm
dragging
looking.
is a very weak thing. Is a very negligible thing.
It says here, right? I'm looking at a Wikipedia page that 532 units arcsec per Julian century. 532 units is gravitational tugs from solar bodies. The next thing is 43 units is from gravito-electric effects. When I look at gravito-electric effects, it says here in Wikipedia, it's from Oliver Heaviside, Corrections to Newton's Law of Universal Gravitation. And they say that it's Gravity Pro B discovery of the frame dragging precession. But frame dragging precession, as far as I know, it's from Earth rotating. That's what's causing it. So if that's it, then it must be that the sun's rotation must be causing the frame dragging that's causing the precession of Mercury. So what am I missing?
No,
Okay, explain.
that's you. How am I
By
supposed to
reading,
explain the thing when you didn't? When you just said the thing and then made a conclusion that the thing doesn't say.
You want me to repeat step by step and you'll correct me when I'm wrong? Or it's up to you. Like you
You're
want?
God. No, I don't. I don't want you to repeat it.
Do you want
You're
to?
saying gravimetric effect does not mean frame drag.
I'm looking at
That's your main issue is that you're equating the entire thing of gravity and I'm guessing electromagnetic effects with frame drag. And that's not correct.
I'm looking at Wikipedia, gravito-electromagnetism. There's a diagram. It says, diagram regarding the confirmation of gravito-magnetism by gravity probe B. At the center, there it says frame dragging precession. And we know, as far as I know, it's caused by Earth rotation. Tell me what I'm getting wrong.
Okay, so now from what you read, it sounds like they're using an effect to correct for the frame drag.
As far as I know, frame dragging is caused by Earth rotation. So that's what everybody said. That's what I know. So explain what I'm wrong.
Okay, so from what I heard from I think it was either Totoro or Sea Lion. It's not caused by Earth's rotation. It's caused by the rotation of a dense body.
Like the sun? We're discussing.
Any sufficiently dense body.
Look, we're just discussing what's causing Mercury's precession. So I'm asking, as far as we
a bunch of things.
Sure. So okay. So again, 532 units in Wikipedia is from other like solar bodies, and the second
what's 532 units?
A unit is an arcsec.
Units of what?
Arcsec per Julian century. So number one is 532 units. That's other solar bodies. Number two in importance is 43 units, gravito-electric effects. When I look up gravito-electric effects or gravito-electromagnetism, so the diagram talks about gravity probe B and frame dragging precession. Now, as far as I know, correct me if I'm wrong, frame dragging precession is the Earth rotating. So I'm asking, so Mercury therefore sounds like it's precessing because of the sun's rotation. Am I wrong? What's your opinion? I don't know. Either way, it looks like Oliver Heaviside explained it. It says here, in 1893, before general relativity, Oliver Heaviside presented it as a separate theory expanding Newton's law of universal gravitation. So this somehow worked itself into GR. So it doesn't sound like GR is the is the is the solution to the precession. It sounds like it's Heaviside's correction through gravito-electromagnetism, which is
Mr.
nothing
Slave, can I say something?
which has nothing to do with electromagnetism. It's just frame dragging.
Mr. Slave, I will say it very respectfully and not at all.
I muted you, so I don't know what you're saying. So, so again, it sounds like the sun's rotation is causing Mercury's precession. Let me ask ChatGPT. Is the sun's rotation causing Mercury's precession? No, the sun's rotation is not the primary cause of Mercury's precession. Oh, but they do contribute, not the dominant. Okay, but it sounds like it's the sun's rotation. So that's the answer? He left. He got tired of talking about me. He has nothing better to do with his life. So it sounds like the sun's rotation causes frame dragging, whatever that is, which causes the precession. How does it do that? Okay, it's frame dragging, however that works. Which, as you said, works well with Aether. There's no issue ultimately with Aether. Okay. Anybody else wants to say something? Oh, everybody moved to the other. Mm-hmm. So it's frame dragging. That's all it is. So the sun is frame dragging Mercury. Oh, there's 2 people watching. That's good. So that's the answer. So the answer, either way, So here, let's go through this step by step so everybody sees it. So these are right. We're looking at the precession. The sources of the precession of the perihelion from Mercury. It's mostly caused by gravitational tugs of other solar bodies. Okay. The second most important contributor is gravito-electric effects that have nothing to do with electric effects. That's just the name. It's frame dragging, which is a general relativity effect. That's what it says here. Shroud-child-like. I don't see that. So anyway, what is gravito-electric effect? So if we go to Wikipedia, gravito-electromagnetism, so we can look at this, but it says here, well, it says that the analogy and equations differing only by some small factors were first published 1893 before GR by Oliver Heaviside as a separate theory expanding Newton's law of universal gravitation. Okay, but more important is this diagram where it says, well, I think we should go back to here. So, diagram regarding confirmation of gravito-magnetism by gravity. Gravity probe B. So, gravity probe B discovered basically precession. They say here geodetic precession, frame dragging precession. So, there's geodetic precession and frame dragging precession. So basically, I think frame dragging precession, it points, it changes the direction so they just put, you see these circles over here. So these circles, these four things, these four spheres, those are just gyroscopes. Amazing gyroscopes. So all that the gyroscopes discovered, they just changed direction over time. They were pointing at guide star IM Pegasus or Pegasi. And slowly they shifted away. Right? But it's a perfect gyroscope. So how could it change direction? So changing direction because of frame dragging, because the ether is flowing in, like in my theory, the ether is flowing in at an angle. It's not flowing in head on. And the angle is caused by the the Earth's frame dragging. So the Earth is swirling a little bit, swirling the ether. As the ether flows in, it swirls a little bit because the Earth is rotating. And this swirling effect it points the gyroscope in a different direction. So originally they calibrated all gyroscopes to point at this star, and slowly over time the gyroscopes started looking away. And that's the discovery. 39 milli-arc seconds per year. The geodetic precession, I don't think there's anything interesting about that. I don't remember what's causing that. Geodetic, and this is the frame dragging. Interesting. Here is c squared r cubed. That's frame dragging. C squared r cubed. Well, GM. Where's M? Why isn't M here? Anyway, so that is. So you could say it's it's reorienting or recalibrating Mercury's precessions. Like the entire orbit is rotated just by a little bit. So that's the answer, is because the sun is rotating. So we asked ChatGPT, is it the sun's rotation? It says, no, it's not the sun's rotation. Mainly, the sun's rotation and its slight oblateness, non-spherical shape due to rotation do have very small effects. They're not dominant. Yeah, I'm not asking if they're dominant, they're second dominant behind the anomalous precession. What causes the precession of Mercury refers to the gradual shift of wobble and the orientation. So gravitational with other planets and relativistic effects, 43 arc seconds per century in Mercury, could not be explained by Newtonian mechanics alone, leading to a long-standing anomaly. This discrepancy was explained by Einstein's theory of GR, but it's just frame dragging, which can be explained by the ether. So it's ether compatible. So that's not a problem. Plus there's oblateness. How much is it? The oblateness. The oblateness is minimal. That's like insignificant. It's 0.02, so that's nothing. Mm-hmm. Let me ask them if they want. Does anybody? Can I ask a question? Does anybody want to see? Does anybody want to? Does anybody want to see me derive gravitational lensing or gravitational time dilation from the ether model? Well, I'd love to put in the paper. Just tell me if you're interested in me put if that's the question. Do you want me to write? Uh, sure. Do you want to join me in my VC? We'll do it like in 10 minutes. I mean, it will take 10. Anyway, you said you want to be my co-author, so like, do you? Yeah, it's. I wanna. I came here to ask. Wait, nobody can hear you guys. Anyway, look, I just wanted to know if Totoro, if you'd be interested in reading it. If yes, I'll write it like in a couple.
Sure, go for it.
All right. So you want to see gravitational time dilation, gravitational lensing, both?
No, gravitational lensing, and quantitatively, please. So with equations and with specificity, not just a bunch of word salad waffle.
No.
Okay?
All right. So as my here's going to be our idea, Mr. Author, is we're gonna use your model, and we're gonna do this on Desmos, of course, my favorite solver, and we're gonna figure out we're gonna have some parameters for like given paths of light, multiple paths of light, and we'll do it with your model and see how much they match up to reality, right? So we'll do like with varying masses to see what the deflection is. Does that sound good?
Well, I prefer a generalized solution.
I mean, I can tell you.
That's not cool.
So,
well.
I mean, you already know. I mean, the answer is the numerical
Yeah,
answer.
Yes, I expect that this is going to be your answer at the end. So I'd like to see the process how you arrive at this from your ether.
It's
because it's definitely going to be very enlightening. I'd expect the amount of stuff that you're probably going to need for this, or the amount of space, that's probably at least 30 to 40 pages. But so go ahead, if you can crank that out in 20 minutes, that'll be amazing. You'd be the fastest writer in the universe. But feel free to take whatever time you need.
He'll have my help, so it's doable, man. Right.
Oh yeah, sure.
So
Yeah.
So Gamma, you already know the answer. So here's
if Midwit were co-author,
so
we would get 1,500 pages in no time.
So the answer is
yeah.
The answer is that F equals MA and F equals GMM over R squared. Therefore, MA equals GMM over R squared. The M's drop out. Therefore, even massless.
Sorry. Yeah, I already gave you the solution there. So
what do you mean?
That is the solution there in general chat that you want to arrive at. So I'd like to see your derivation of this. Okay, that's going to give you.
Mr. Slave, I think this is going to take longer than 20 minutes.
You know what, Gamma? I do think you should go into a call for 20 minutes with Mr. Slave and figure it out.
Mr. Slave, what is there going to be our starting parameters with the ether? How does?
No, I already gave you. I mean, you cut me off mid sentence. You keep cutting me off.
I said you're going to need at least 40 pages because he hasn't actually specified ether. So he's going to first have to specify what ether is and what its dynamics are.
Totoro, how much money you want to bet I can derive this from Newton? How much money? How much money you want to put on that?
Put some money on it. Let's see. Oh, you know what? I'll make the bet. Let's say £1,000.
Oh my God! Jeez,
But 1,000 right now.
£1,000 is good.
Slave. Yeah. You have 20 minutes
from Newton.
From
Newton.
That'd be. How much money?
That would be.
How much money?
I don't know.
Well, it's important. Think about
first
it.
Thing is, you're gonna have to pull a gravitational. you're gonna have to pull a magical rabbit out of your hat.
Yeah, I told you
mathematical rabbit out of your
hat.
No.
Total, it's perfectly possible. Mr. Slave, 20 minutes, £1,000. Go.
No.
Time starts now.
Totoro, how much money?
I already got.
It's free money, Totoro. Just say a number.
Say a number. Give me a big number.
Hang on, I want to make sure that you understand what the goal is, okay?
Just say the number.
You don't wriggle out. This is the predicted solution. So this is the solution you're going to have to derive.
Mm-hmm.
And you're going to have to do that from ether. You said ether in 20 minutes.
Yes.
All right. Well, how much money?
Well, let's see. I don't know. Let's say $100.
Well, either you're very. Oh, come on! Come on!
Time
$100.
I'm not gonna be pulling a sea lion here, okay?
Ask sea lion. Maybe he.
Right, so I'll lay out the param. Hold on, I'll be the officiator, right? So that formula in the chat that Totoro's posted is what he needs to. What Mr. Slave has to derive with ether, in 20 minutes, and it will start at 1:15. So 1 minute. So it starts. $100. $100.
Okay, Gamma, you gonna help me?
Oh, yeah, of course, Mr. Slave. Let's do it. Let's do it.
All right, let's go. Come to my server. We have 20 minutes. Wait, Totoro $100 and the Fliggily Goo Goo 2,000 pounds.
1,000.
1,000. Good enough.
Yeah. Well, you
Anybody
get
else?
500 now and pronounce his name right.
Anybody else wants free money?
Free money.
Free money. Let's go. All right, Gamma, come help me.
Yep. Yep. I'll join. Yep.
All right, so it should be very straightforward. Do you believe that we can do it?
Yeah. I do.
All right, so let's create a new page. Okay, this is going to be theta. What is it? Gravitational lensing. All right, let's go. So how does it work? Oops. Good. So how does it work? It's really very simple.
This is what we need to arrive at, right?
No, it doesn't matter. It doesn't matter. I don't care. I don't care. I don't need to see the solution.
Really?
No. I don't need to see it. I don't need to see it. Let's go. All right, let's start. Get rid of the yeah, okay, thank you.
Yep.
So basically what we have a source of light and we have some point mass. Let's make it little m. And it's going to bend some theta, right? So this is theta. And all we have is Newton's principle of gravitation and acceleration. Okay. So we know that F equals MA and F equals GMM over R squared. Right, same start as last time. And this is F acceleration, F gravitation. So F acceleration is equal to F gravitation. So we're assuming light is a falling body. So F equals F. Therefore, MA is equal to GMM over R squared. And as always, the m's drop out, which gives us that this is the acceleration of light due to a point mass at radius r.
Yep.
Okay. So, all right. So so basically it's any body, but it's just that at speed of the velocity is equal to c, right? It's like any body that we will release at v should experience this trajectory. There's no difference between any body, anybody with a v or light at c, and that's all it is. So what happens when you have v? So all you need to do is to integrate, right? This is just integration, that there is so this thing, as soon as it gets close, it's accelerating. So if we magnify this a little bit, right, it's just accelerating. There's always acceleration, but right, so we don't care about so much about this acceleration. We care only for the acceleration that is perpendicular to the path, because we cannot change the velocity of light. So we don't care about that. So we're looking at the perpendicular component. And we need to integrate over, right, the whole time, right? There is, sorry. This is the direction of the force, of the acceleration, sorry, there's no force. But all we care for is the perpendicular vector. And we need to just integrate over infinity, from negative infinity to positive infinity. right? Right. This is what it says here. Are you there? Right? You following?
Yes, I'm here. Yep.
So if we just look at the acceleration, this is the acceleration, but the acceleration is always, we look at r as a vector. This is the acceleration as a vector, r is a vector, but we don't want this acceleration. We just want okay.
We just want theta.
No. We just want the acceleration perpendicular to the path. So we have a path, and we don't want the we don't want the red arrows. We want the green arrows.
Because velocity of light is constant. Yeah.
Yeah, the velocity is constant. We're not impacting the velocity, and I'm sure that even if we did whatever contribution to the right, we're going to lose to the left. So that's not going to make a difference. So whatever acceleration we have towards, we're going to have away from. So that's not interesting. So we could probably even integrate without touching the vector, but okay. So how do we go about that? So so I think we should use polar coordinates. So let's go to polar coordinates. That should give us some level of symmetry. So from this is so basically we need to integrate. Like, how do we integrate? How do we define this thing? We need to find the path. Somebody must have done this. Let me check. This is just change of path due to gravitational point mass. So change of path due to gravitational point mass.
You could do momentum principle.
How? Tell me how to do that.
Look up the equation for the momentum principle.
Momentum principle. Conservation of momentum?
No, well, yeah, you can figure out the paths of orbiting bodies, but you could probably do it for non-orbiting bodies as well to figure out their change of direction over time. You basically have initial state vectors, so you would have some defined point at some defined distance away from M, and you'd start off with the velocity and mass, and that would give you your starting momentum. And then over the next time step, the force of gravity would change your momentum. You'd update your velocity and then update your position with the velocity and momentum, and then you would do it again over the time steps since you have a new position, which means you can calculate the force again. Etc.
Let's try to integrate. I don't know if we can do it with polar coordinates. It looks more I saw someone deriving. I mean, this should be derivable. This is so simple. We just need to think about, okay, let's assume a coordinate system. Let's start with any coordinate system, see where that gets us. So let's just assume that this is our what?
Do Cartesian.
Yeah, let's do Cartesian. Let's do X and Y. So we're doing X and Y. And so we're saying that at a certain location, there is a point mass that's creating this acceleration. So we can take any one of these force diagrams and write the equation for it. So the acceleration at x, right? At every x, there is some vector of acceleration.
Yep.
The problem is that we shift. I mean, there is x, but there's also y. But I don't know what are we going to do with y? Like it could be acceleration as caused by both x and y. It's a function of x and y because it's not just a function of x, as it is at x. Well, we'll see. Okay, acceleration is a function of x is equal to.
Well, yeah, theta's going to have both x and y coordinates, of course.
I mean, what we're trying to do is we're trying to calculate, right, the infinite asymptote. Right. Well. Okay. Let's see where this gets. So GMM over R squared. Here's the problem. R. See, what is R? So what we could do, we could define the coordinate system at the center of the sun.
Yep. Yeah.
And then we have R. R is fairly maybe more straightforward. This is a problem because like it starts like with X and Y, and then it like curves around. So by curving around, it's like polar. It's like a polar effect. So it's basically like a little bit of an orbit. So
yeah, that's why I said momentum principle, baby.
But you still need. No, there's no momentum because there's no mass.
Yeah, that's the unfortunate part.
But it doesn't matter. I mean, we could dream up a test particle. A test particle, right? If you fire some cosmic particle, a proton, right? You can fire a proton at almost c. It's going to follow the same path. That's what it says. That is the equation. That is Newton's equation. That is Galileo's principle of equivalence. That all bodies fall at the same rate. So it doesn't matter what the mass is. It just depends on the velocity. Anyway, so we could just we can just take this little area over here and just think of these forces. See, the acceleration is always towards r. So let's change this. Instead of a of x, it should be a of let's call it phi. So we'll have some. Let's say that this is phi. So this is r. So a at phi as a function of r. R changes. R is always different. R at phi. So the radius is a function of phi. Like we know that when phi, right? Phi. it's never there, but right, the test particle light starts at negative infinity. At negative infinity, you can almost argue that phi is equal to like negative 90 degrees. Right, if this is phi, well, if this is phi is positive 90 degrees. If phi goes counterclockwise, this is phi equals 0, let's say. So at phi equals, as phi wants to go to negative 90 degrees, r goes to infinity. Right? The radius is infinite, and at infinite radius, acceleration is 0. Do you understand?
Yep.
Okay. So acceleration is the function of phi, is gm over r as a function of phi. So everything is a function of phi squared. That's the acceleration. Now we're not looking for the acceleration at phi. I think we it's okay. I mean, whatever acceleration to the right, I think we're gonna lose to the left. That's like my assumption. Or do you want to? Because otherwise, it's going to be difficult to take. I'm going to assume that it's fine. What do you think? Or do you want us right now to take the component perpendicular to the path? My assumption is.
Why do we?
Yeah.
Why do we have to? What's your love with integrating over infinity?
My love? You have to integrate over infinity. What do you mean?
You don't have to integrate over infinity. You can integrate over 1,000 kilometers to some other distance.
Yeah, it's usually easier over infinity. It's just easier. Like infinity gives you 0 and the answer converges to some number. It's just
yeah, that's true. But I mean, I feel like it might make the math easier since you'll be starting with like.
No, well, look, if the math if something becomes difficult, we'll go back, back to the beginning. So we're saying, So we're saying that, and by the way, we said we're going to do this from Aether, but Newton, the inverse square law is based on the Aether, so that's fine. We can always derive Newton. We can point to Leonard Susskind deriving Newton from a fluid in his second lecture of GR. So that's already done. All right. So this is the acceleration. It's gm over r squared as a function of phi. And all we need to do so what's that going to give us? So if we integrate it, we're saying, okay, that's the acceleration. But we want to get theta. I mean, how does any acceleration impact theta? So what is we didn't talk about theta. So that's some acceleration in the direction of r. That's nice. Or in the direction of negative r, this is probably negative. Because assuming this is if we assume this is positive r, so the direction is negative. Okay, that's fine. But the question is, what is theta in relationship to this discussion? So I think we have no choice. We have to convert to x and y.
Yeah, yeah. Only if light had mass, then we could use the momentum principle.
I told you can take a proton, fire it v equals 0.999999 c, and you'll get the same answer.
That's true. That's actually true.
You could
Yeah.
take water. You can fire a water stream at C. You'll get exactly the same result. That is what it says here. It doesn't matter. Little m cancels out. So you can do whatever you want. You'll get the same answer. This is from
All right,
Galileo.
we have to go back. It's been 20.
No, let's finish. I don't care. We need to finish. I'm not. I mean, we don't have to. We can do it in 20 days. This is a paper. You said you want to write a paper. You want your name on a paper. So let's finish. So the question is, how do we convert? What is theta? So there is some asymptote. At the end of the day, there's some asymptote that has an equation y equals mx plus b.
That's a parabola.
Y equals mx plus b is a straight line.
Yeah. Okay. Yeah. No. Yeah. That would be x squared. Yeah.
Right. The straight line. There's a straight line here. So the straight line is y equals mx plus b. That's the asymptote.
Yep.
Whatever. All right. So that's the relationship ultimately at infinity, at positive infinity, y equals mx plus b. I guess we can introduce it. Y equals mx plus b. I don't know what we're going to do with that yet. I mean, that's critical. So theta is just m. So, okay, we have theta. Theta is just m. That's all it is. So we know theta as a function of the asymptote, whatever. What else we got? What else do we know about this thing? And at positive, r equals positive infinity, it looks like the r is the asymptote. What do you think? At positive infinity, r is the asymptote. Do you agree? Right here, let's look at infinities. So, right at infinity, so let's say the sun is here and a trillion miles away, the light started from this star.
Yep.
Right. So basically, the sun doesn't count. The sun doesn't have right. This curve doesn't exist when you look at infinities. It's a straight line and a straight line. And this is and this is theta, which is m. And this is y equals mx plus b. So this is
the difference in theta would be m. The difference in theta would be m. Yeah. Or the difference in m would be theta between the two. Yeah.
I mean, it's right here. Let's drag this all the way to here. This is the x, and this is theta. So you see how it's the same theta.
I know what I'm saying.
But this is m.
The difference is
no. There's no difference. Yeah. This is m. M is rise over. It's rise over run.
I understand. Yeah.
Rise over run. So that, as far as I understand, this is theta. So there's no problem. So theta is just m. So at infinity, so at negative, right? This is the okay. So, but what we're saying is the radius, the positive radius. This is the positive radius at infinity, and this is the negative radius when we're talking about infinities. This is radius initial, and this is the radius final. So the radius final is y equals mx plus b. This line is the final radius. At least the right that but something like that. So this is y equals basically y equals 0. Y equals 0. I mean, depending on where our coordinate system is. So if we say that our coordinate system is, we have to decide, but let's say it's here. This is our x and y. If this is our x and y, then we're starting from just y equals 0. X equals, we're starting from x naught is equal to negative infinity. Y equals 0. Right, that's the star. That's where these are the coordinates of the star, right? This is y naught, right? This coordinate, if this is our y and x, right? Are you following?
Yeah, I'm typing right now to
To
explaining my to Toro. I'm trying to explain the momentum principle thing to him, but I'm listening. Yes.
Yeah, you don't worry about them. Don't worry about them. This is for you. You're curious to see that we can prove it, right?
Of course, yeah, I do.
That's all that's important. We're doing it just because we're having a good time. That's all. Anyway, because it's a puzzle. It's fun to solve puzzles. It's like playing a game. It's like a video game, but you can get a Nobel Prize from this.
Yeah.
All right. All of GR is derivable from Newton, from Aether. So I think that's worth a Nobel Prize. Anyway, so we have y and x. So basically, you could say that we're starting from something like this. At the y at 0, 0, this is the middle point, and we're ending at x final. There is no x final. There's just at the end. There is a relationship at the end. At the end, y final is equal to m. X final. There's no b because it intersects the coordinate system. So it's very convenient that we have this x and y at the sun. So x and y is the sun. Therefore, y final equals mx final. There's no b. B final, b is equal to 0. So we just discovered b equals 0. Do you understand?
Slope intercept form is a little out of my depth, Mr. Slave.
Wait, y equals mx plus b is out of your depth?
No, I'm joking.
Okay.
I'm joking.
I realized that halfway through asking. All right. So what is theta? Okay, so we have this interesting equation. We have this interesting initial condition. We have this interesting thing, maybe this interesting thing, a bunch of interesting things we gathered already. So let's get back to the infinities. Maybe it's the simplest thing over here. So what we have is, so we have some acceleration that's experienced over this path and some acceleration that's experienced over this path. But I think we need to look at the actual curve, right? This is like some part of an orbit. So this is the acceleration. Acceleration is negative gm over r squared. So we can integrate from, right, we're talking about phi, from phi equals negative infinity to phi equals positive infinity. Let's write that. So the summation of the, let me just take the whole thing with me. So let me take this thing with me and copy it. So I'll paste it here. Okay, so let's integrate. So integrating both sides, but we don't have any differential to integrate over. So we need to integrate over d phi. So the integral, I can't use yellow, that's not good. So let's use green. Okay, so the integral of a of phi, well, we know it's a of phi d phi, right? As we're moving through d phi step by step. For every d phi, we're integrating negative, well, let's just pull out the constants, negative gm integral of 1 over r again of phi d phi. And r, the same as a, is a function of phi. For every, so now all we need to do is create the function r of phi, and we don't need to create the function a of phi, because the integral of a of phi d phi, what is it?
Of a of d phi.
All right, every time we're taking, what is a d phi? What is a d phi? So we have a little bit of acceleration over a little bit of phi. A little bit of acceleration, if we, right? So if we draw a little bit, so here is a little bit of d phi. It's infinitesimal d phi. This is an infinitesimal d phi. This is r of phi. And this is also r of phi, but whatever. And during this time, we have acceleration. So because of this acceleration, we're going to have this. We're going to change the path by a little bit. There's going to be a little bit. This is, what is this little angle? So this is d theta, actually. Wait, why did it write? Did you do that? So
No.
So this is d theta, I believe, right? Because if we look at the bigger picture,
It's diverging from the,
right? So every little bit of a is giving us at the end theta. So the integral of a d phi, a little bit of a d phi, more at the end, from negative infinity of phi, from negative infinity phi to positive infinity phi, whatever. If we go through all of phi, well, we don't have negative infinity. We have negative 90 degrees. Phi goes, right? Phi goes, we said, when looking at the infinities, we look at y and x, right? Phi is negative 90 degrees to phi equals theta, right? Phi starts from negative. Phi at y, the y-axis, phi, we decided phi is 0 at the y-axis. Anyway, so it's not from negative infinity to positive infinity. Phi is equal to negative 90 degrees to theta. Do you agree?
That's something more workable. Yeah.
Oh, okay. And we need to say the same thing over here. It's the same thing. It's d phi, right? This is r of phi. It's also from negative 90 degrees. This is degrees to theta. But this is 1 over r squared, I think. Did we? Yeah, it's squared. So this is r of phi. R as a function of phi, but we don't have r. We need r as a function of phi. What is r? Actually, we don't know what is r as a function of phi. I mean, r, we're looking for, oh my God, you're not going to believe it. This is a Lagrangian. Did you ever learn about Lagrangians? That's why it's
No.
difficult. Yeah, it's a Lagrangian. We need, right? We need to find the path. We don't know what this function is. We don't know what the function looks like. We're looking for r of phi. That's what we don't know. What will the universe select to be r of phi? We don't know what r of phi is. We can't integrate, right? Because right now, I want to integrate r of phi. It's not a constant radius. It's not an independent variable. It's a function. It's r of phi. It's some crazy function. So so we can't solve it this way. We must use a Lagrangian. Have you ever learned about Lagrangians?
No, I'm reading it now, so it looks like it's the total kinetic energy of the system.
No, that's the Hamiltonian is the total energy of the system. The Lagrangian is we can use the Lagrangian. We can use the principle of least action. Have you ever heard of the principle of least action?
No, I just learned Newtonian mechanics, man.
So after Newtonian, the next step is Lagrangian mechanics. So Lagrange, who is that? Fligugugu. By the way, rules of the bet. You
What do you
owe
mean,
me
rules of the-
1,000 pounds.
Did he DM you?
What?
Did he DM you?
Yeah. Okay.
I think we should go back in there real quick. Hold on.
No. I
Come
don't want
on,
to waste.
come on.
No, I don't want to waste my time.
We're not gonna waste time. We're not gonna waste time. I
no,
think we should.
no.
We should get some input. We should get some input.
No. Stop. Those guys, they just want to waste time. Come on, stop. You're not doing anything for yourself with these guys. They're just wasting your time. Look, we can look up. I mean, we're not going to be. Somebody probably already used the least action to calculate theta. I don't think you need GR for this. I mean, this is just an asteroid being deflected by. Somebody must have done this. This is just.
That's why I said we can do it with Newtonian. I kept on saying momentum principle. Just do it with a small mass, going like very high fraction the speed of light.
But you have to still use a Lagrangian. I don't think you can get away from a Lagrangian from the principle of least action because you need. Okay, let's look up how to find the deflection of asteroid by Earth. Estimated deflection of asteroid near Earth. Let's see how he does it. Let's Let's see what he uses. Are you looking for something similar?
Yeah. Gaussian mechanics, gravitational deflection.
Yeah, it's just gravitational deflection. That's all it is.
Yeah, that's what I'm looking up.
The question is, he just gives the velocity. We need... delta t. The question is, if we're not looking for... You need to let me look again. We're integrating R. What do we know about R? What do we know about R? Do we know anything about R?
Well, you defined it as being an infinite distance away, correct?
No, R. R. It passes by. Right, R. Right, R is right. We're forget about light. Think it's an object. You're throwing an object. The closest it's going to get is R to the planet, and therefore it's going to get deflected. Because of gravity, it's going to get deflected. So R is as close as it's ever going to get. That's the nearest by. That's R. We have an R of theta, that's R of phi, that's different than the nearest R. So the nearest R but when it's at the nearest R, no, it's never at the nearest R because it's already starting to curve before it gets there. Anyway, let me look up. You know what? Let's ask ChatGPT. Okay, let's make it simple. ChatGPT. So, given an asteroid incoming towards Earth, it will pass near Earth at radius r. It will be deflected due to Earth's gravity. The deflection angle is theta. What is theta? Given what are we given? Just Earth's Earth's mass m and the velocity of the asteroid is, let's say, c. The deflection angle theta of an asteroid as it passes Okay, that's the answer. Exactly what they wanted. So that's it. Oh, yeah. So that's the answer. Is that the answer that they wanted? Let me copy paste it. We should have done that first. Could you show me their answer? The answer for an asteroid is 2gm over RV squared.
That sounds right.
So that's it.
Yeah, that. Well, wait, two. Yeah, no, that sounds. Yeah, that's right. Yeah.
So that's the answer.
Yep. And the deflect, it's theta equals that. Theta
Yeah,
equals 2gm.
I just copied.
Yep.
I just copied that from ChatGPT.
Yep.
So you see again and again. I mean, and this is why Einstein became famous. So
But V is going to equal C, of
yeah,
course.
of course. So you see,
So it's
but this my point is Einstein became famous for a misunderstanding. This is why he became famous. This is why he became a superstar, because of a misunderstanding. Here's the explanation. Do you want to go break the news to them?
yeah. Let's do it.
No, you can do it. And then you can.
No, come on.
You look.
All right, I'll
Why
come
don't you
back.
go, come
Yep.
back, and we'll write the paper like normal people.
Yep, of course.
Okay. Okay, so what I wanted to show the next thing that they're gonna look for is derivation of gravity from, so derive, how to derive Newton's gravity from Gauss's theorem. So derive Newton's law of gravity from Gauss's theorem, also known as spherical surface. Okay, I mean, here it is if you want to see it. Here's gravity from Gauss's theorem, and Gauss's theorem is just a fluid flow. So derive Newton's law of gravity from Gauss's theorem, also known as divergence. What? Cash app. Yeah. Yeah. No, but I sent the submission. We already sent the submission. I sent Gamma. Gamma went to talk about it, to explain it. A little late. Yeah, I know. Once I get the Nobel Prize, I owe you. I did. You're right. You're a good guy. You did a good job. Yeah. Yeah, I'll talk to. Send me your cash. Send send me one of your preferred choice. Okay. Anyway, um, how do you copy? Let me see. Copy. Of course. Yeah. I mean, oh, here it is. This is the here is the rest of it. This is now the derivation directly from the ether. So, I mean, Newton from ether is trivial. So I'm having a hard time copying and pasting it. But ether is just a fluid, so that's Gauss's theorem. So Gauss's theorem is how to derive Newtonian gravity. Okay, 1 second. Let me just copy paste this. Okay. So wait, remove this. Instead, send this. So, okay, come to Globe Gangsters. Where is everybody here?
Sure doesn't exist.
Yes.
I mean, I'm not playing.
Hey, Mr. Slave. So where's our money?
Give me my money. But okay, so we submitted a little bit late, but
Yeah. So that means you lost.
Yeah.
I'm glad you conceded there. Good stuff. So
yeah.
now money.
But you agreed.
Yep.
That,
I have an idea. How about we deduct, so the amount of the error margin we were off is the amount of payout you get, right? How about that?
no, it's fine. It's
I've
fine.
just set up a PayPal, right? So he's gonna give me my fucking money.
I said I'll give you your money when I get the Nobel Prize.
No,
You did not. No. You.
What do you mean?
You did not say that. You did not say that.
No, I didn't say when.
Doesn't matter. That's not how bets work. You don't get to like go. You know what? In a million years.
Why not? Says who? By
That's
who?
not how it works.
I'm pretty sure it does.
It's all right. I've just set up my PayPal. All right. So
send me your PayPal.
just,
send me your PayPal.
Yeah.
And as soon as I get the money for the Nobel Prize,
no.
There we go. Wiggling out of the bet. There we go. Spoken like a true pseudoscientist.
Anyway, Gamma, are you driving?
I am driving. Yes.
I
Why?
see. No, because
He's
we were.
going to find the Nobel, the Northern Lights.
Yeah.
Well, I'm not driving right now. My dad is, but you know.
Oh,
I hired him as my collection agent.
Anyway, so we can. I mean, I'm glad I got motivated.
How's this as a solution to the bet? You don't get to speak on the server until you pay the bet.
No.
Which you lost.
No, that's not fair.
That is fair. That is fair. Those are the rules.
You can.
There's got to be. Look, if you miss a payout, right, you've got to take a punishment, right? Like that's got to be it. You can't just like make bets and then say, "Oh, you know what? Now that I've lost my bet, I'm just gonna, like not pay out."
You wouldn't think so.
Seafoam's paying his off.
Sea Line, yeah. Sea Line is paying off his $10,000 bet
To
to Shane the plagiarist.
To
Shane the plagiarist. Shane Saint Plagiaire.
What? He's paying $10,000?
Yep.
Yep. You know, I'll even let you play it in lump sums. You can pay me 100 now, and then £900 some other time.
Wait, is that true, Omnivore? Are you actually paying somebody?
Because betting
Not
is illegal.
Omnivore.
Betting is
Sea Lion.
illegal.
Or Wand.
It's a contract. If you
Sea
make a
Lion
bet.
is paying somebody.
Yes.
Yes.
Shane the
Why?
plagiarist.
Why?
Yes.
What debate was? What debate did he lose?
He bet that he made a bet that a flat earther couldn't do cell nav, but the way it was worded, it was, Shane was able to do it on a globe and then do a transform to bring it to the flat earth.
You think was that in writing? Did someone say?
I think he put the bet on Twitter. I'm not sure.
I would, if I was him, I'd say that's not in the spirit of the bet, at least, right? I mean,
possibly, but technically, well, kind of a good question.
Well, not only
was it?
that,
Was it not?
Shane's just proven that it can't be done on a flat Earth. The only way he could do it was to do it on a globe and then transfer it over.
Sure, yeah, but technically, he still met the burden of the bet.
That's
yes,
why.
but it depends on how anal you want to be. I mean, like for me, I would say that's not the spirit of the bet. Come on, we know what I meant when I said that, right?
Yeah, okay, you guys won fair and square, so I definitely owe you the money. No questions asked. So
yeah.
send me your PayPal, Cash App, whatever, and as soon as I have,
Hey, yeah.
as soon as I get my Nobel Prize, I'll send you some.
Oh my god!
So that means never. Okay.
What a
thanks.
tease, Mr.
So
Slave.
It does
now
not
we
mean
know
never.
that.
It does not mean never.
So we know you're not a non-paying deadbeat. Okay.
Yeah, pretty much. Anyway, Gamma, do you wanna? That was what was that? That was that's why Einstein became famous. So we just proved that he became famous for no reason. What else did you want to
for
see?
not paying a bet?
Where did that come from? Where, Mr. Slave? I know we have a good cohort together as colleagues of this paper, but what was that about? What do you mean by
Einstein
that?
became famous when exactly for that experiment that Lord whatever, they went to Africa to see the eclipse of the sun, the total eclipse of the sun, and they saw a star in the sky that should not have been there because Einstein predicted that the curvature of space-time is going to curve light, and they're going to see the star, even though it's behind the sun. And the next day he became the most famous scientist since the beginning of time. And now we know it was a mistake because it's just the deflection of an asteroid. So there's nothing special about light. It's completely predicted by Galilean and Newtonian gravity, which is just
right. So you didn't even read the Wikipedia page I linked you. Okay.
What?
It addresses that.
What do you mean? What I gave you? It's the same equation.
Nope.
What do you mean?
What is your answer? What did you come up? Well, what did ChatGPT really come up with? Because you didn't. Because I was watching your stream.
Oh, it's 4gm over c squared r. What did we say?
You said 2gm over c squared r. If you've read the Wikipedia page, it would tell you that the Newtonian derivation is off by a factor of 2.
Oh, wait, what?
Yeah.
Mr. Slave, this is what we need to do. We need to algebraically manipulate this equation so we can get 4.
I mean, why?
Yeah.
Wait,
Well,
why?
you can have to justify it.
We just have to. No. We just have to.
Yeah, you just have to rederive general relativity to do it.
You just have to just bullshit to the point where
You just
people
have to
can't figure out if your math is where it'll take somebody like 1,000 hours to go through your mathematics, and ain't nobody going to do that.
Also, by the way, you agreed to do it from Aether, not from Newtonian mechanics. You said from Aether, so I would expect to see you first propose your dynamics of Aether.
Here's the Aether
You didn't do
part.
that either.
Here's the Aether. So Aether.
I mean, the answer is wrong. So
no, Aether to Newtonian is easy. I mean, I told you already many times. Lenny Susskind derived it, and it's easy. So ChatGPT immediately gave me Gauss's theorem, which is Aether. It's a fluid to Newtonian. That's like one step. Just basically, Newtonian gravitation is just Gauss's theorem. That's it. That's all you need to know. And Gauss's theorem is just Gaussian flow. Gaussian flow is just a fluid. So it's simple fluid flow that is Newtonian gravitation. So Newtonian gravitation is just ether, nothing else. So the question is, why is there a factor of 2? I remember Einstein had this factor of 2. So what's the story?
You did? Because you didn't even know about it.
No, stop it.
I mean, you probably remember it from 30 seconds ago when I told you about it for the first time.
Okay, whatever. So I'm wondering what's causing it. Let me check. Let me see what's causing it. That's now I'm curious because there shouldn't be a difference.
What was the deal with seeing the star they shouldn't have seen and the asteroid?
There's no difference. I mean, Newtonian gravity doesn't care about the mass of the asteroid or the speed of the asteroid.
I mean, I'm just claiming what you. So you're saying Einstein got it wrong?
No, I see now Einstein got a different answer. So I'm wondering, why does GR predict a different number? So let me check. Let me look into it. In my understanding of the universe, there should not be a difference. But fine, I might be wrong. You guys, what do you think? I'm here to win. I'm here to find out who's like if I'm right or wrong. So
yeah. You've already lost. That's a
yeah. Just to play, you realize that we would have arrived at the same point we did now, but like we would at least have arrived. It would have been off by 2 orders of magnitude. Well, not yeah.
Yeah, a factor of 2.
A factor of 2. If we just went with momentum principle and you just trusted me, we would have gotten the same shit. We would have got closer to the problem. We would have figured this out easier.
No, my question is, I don't understand what is this factor of 2. I need to figure it out. Yeah. So why is there a factor of 2? So I need to look into this. I'm curious now. Why is there a factor of 2? Let me look. Okay. Gamma. I'm gonna go and come back and I'll look into it. Bye.
All right.
Okay.
Okay, why? Oh, okay. So why is there a factor of 2? It's 2gm over rv squared, and they said that it's 4gm over rv squared. Why is there a factor of 2? Near Earth, due to Earth's gravitational field, can be determined using principles from orbital mechanics, specifically by treating the asteroid as a hyperbolic orbit around Earth. We can use an approximate formula derived from gravitational scattering. Explanation: deflection small for high velocity objects like asteroids. For the formula assumes that the asteroid is moving fast enough. Oh, there's a fly in the ointment. How did you get here? Anyway, so why velocity conservation? If the asteroid's velocity v equals c is very high, the deflection will be small. The faster the asteroid is moving, the less time it spends near Earth and thus experiences small gravitation. Closest so why is there a factor of 2? Okay, why is the deflection of light double that of a massive particle? Deflection of light by a massive object like the sun is double that of a massive particle following similar to X-ray because of the combination of both space-time curvature and special relativistic effects predicted by GR. Let's break. Newtonian prediction for massive particles is 2 gm over RC squared. Einstein calculators show that deflection of light is 4 gm. This is double. Why is deflection double? The doubling happens because Newtonian gravity only considers the gravitational force acting on massive objects, while in general light is affected not only by the gravitational force of spacetime, but also by how spacetime and time themselves are altered by the presence of mass. Light travels in both the curved space and the curved time, which together produce the extra deflection. What? In essence, the Newtonian approach assumes a single effect, the gravitational pull on a fast-moving particle. In general, light experiences space-time curvature in both dimensions of space and time, leading to twice the deflection. What? The doubling of deflection of light was confirmed during 1919 solar eclipse by Arthur Eddington, when light from distant stars passed near the sun. It was deflected by about 1.75 arc seconds, which is double the value predicted by Newtonian mechanics. This observation provided strong evidence in favor of Einstein's GR. It doesn't matter, really. I mean, it's just saying that I'm missing something in GR. I'm not, like, I have all the principles. The principles are fine, except for something about GR. Something about GR makes it double. Two GM. So why? So I need to learn. GR. There's no way out of it. I need to figure out GR. This is really weird. It's really weird that they know that Newtonian prediction for massive particles is half that of Einstein. So where is the doubling effect coming from? Why is light double? What's special about light? Like an electron beam. How would an electron beam deflect? How would a proton at the speed of light get deflected? This is really strange. I mean, what happens to a particle at the speed of light? So an electron at the speed, traveling at the speed of light. What if we have an elementary particle or a subatomic? If an elementary particle is traveling almost at light speed, or given An elementary particle is traveling almost at light speed. It passes by the sun, passes near the sun. The sun's gravity causes it to deflect. Sun's gravity causes it to deflect. To deflect by angle theta. So the sun causes it to deflect by theta. What is theta? There it is. That's light. I don't want light. I want a particle. Deflection angle of another measurement traveling near light speed as it passes the sun due to the sun's rays. We can approach this problem using general relativity since the particle is moving almost at the speed of light. The deflection will be similar to the deflection of light, but slightly less due to its non-zero rest mass. General relativistic deflection in light is this. For near light speed particle, since the particle is traveling at a speed close to the speed of light, we need to slightly adjust the formula to account for the fact that its velocity v is less than c. The deflection angle is still the same. Thus, deflection angle is inversely proportional to the square of the velocity of the particle. Step-by-step process. Substitute the velocity vc. I don't care. The question is, why? What's the calculation? What's as the particle becomes faster and faster, what happens to it? Why does it? How does this arrive? How do we get to 4? Just because the particle is faster and faster? Why? So theta of a particle is 4gm over rv squared. Why? Theta of a particle is twice that of light. Okay, let's ask, why is it twice that of light? Why is theta of massive particle twice that of light? It's not generally twice that of light. In fact, the deflection angle of light is typically greater than that of a massive particle in gravitational fields, especially particles moving close to the speed of light. This is light. This is a particle. Now it's equal to. If we treat massive particle in relativistic framework, the deflection angle is approximated by white light is deflected more than massive particle. Space-time curvature. Light is maximally affected by space-time curvature because it travels at the speed of light, and general relativity predicts a stronger deflection for massless particles. No, it's got nothing to do with massless particles. It's got to do with the speed. I mean, I can throw an asteroid at the speed of light. It will deflect like light, which is weird. It's like as I'm approaching light speed, my deflection is increasing asymptotically to twice that. But in the beginning, whatever the velocity is, it's some equation. As the speed gets closer and closer to the speed of light, instead of being linearly or whatever, it starts growing asymptotically to twice. Why? Velocity. Massive particles traveling slower than light experience less deflection because their velocity v is less than c, and deflection decreases with the square of the velocity v squared. A massive particle moving at a velocity much lower than c experiences less deflection than light. For a relativistic particle moving near the speed of light, the deflection angle will approach that of light, but it will still be less than. The confusion may arise because Newtonian mechanics predicted a smaller deflection angle for light than for massive particles. In Newtonian framework, light would be deflected by a smaller amount because it was thought to behave like an ultra-fast particle. However, general relativity corrected this view, showing that light's deflection is greater due to the effect of space-time curvature. What effect? What effect? I don't understand the effect. Okay. I don't know what effect. I don't know what effect. Yeah, I gotta do GR. There's no way around this. I gotta do GR. Wait, what did he say? Proof of calculation of the advance in the perihelion of Mercury. Oh. Oh no. Oh my god. Nuclear drive? What is that?
When it comes to the search for extraterrestrial civilizations, extraordinary evidence requires extraordinary funding. If we had invested $10 billion in the search for extraterrestrial civilizations, similar to the budget allocated to the Large Hadron Collider or the Webb Space Telescope, we might have already found our cosmic partners, and the cosmos might not have been as lonely and dark as it appears to us now. Over the past 70 years, we searched for radio signals from other intelligent civilizations, but this is like waiting for a phone call. Nobody may be calling us while we are waiting. A better approach is to search for packages that might have already arrived at our mailbox. The senders may be dead, but any trash they left behind in the ocean of interstellar space could be our treasure. This is a quote from the latest article from Dr. Avi Loeb entitled Alien Hunting. The reason he's chosen to release an article like this right now is because the results of his search off the coast of New Guinea for UFO debris or debris of some sort of interstellar object that struck our atmosphere on January 8th, 2014 has finally borne fruit. They now have the final results of the chemical analysis of the tiny spherules that were discovered off the coast of New Guinea, spherules that definitely came from an object that originated in outer space, spherules that bear a great deal of resemblance to the types of spherules that we would expect to find in the aftermath of a meteor impact, but the chemical composition after a year of analysis has proven that this debris definitely did not come from our solar system. Indeed, it bears no resemblance to any meteor or any asteroid that we have ever discovered in the past. As a matter of fact, it bears no resemblance to much of any sort of natural material that occurs here in the solar system.
We'll come back to this. Towel is very powerful for self-defense against a knife. Yeah, against a knife, you want a towel. That's exactly what you want to do. Yep. Just take off your shirt. That's the first thing you do. Take off your shirt, take off your jacket, wrap one hand to protect it. Definitely. Yep. But, V doesn't understand logical structure, most fundamental structure in physics. Yeah, it looks like we need to do some GR. There's just no way out of this. Wow, real analysis. This kid, he's not joking.
Counter, but he began to feel, quote, suspicious.
I'm thinking So I have an update to the story of a transgendered woman who tricked this man into having sex with her. And then when he realized she was transgendered, he shot her.
He told police she approached him for a sexual encounter, but he began to feel, quote, suspicious.
I'm thinking he thought it was a girl. It's like, oh man, yeah. She just said if I want to get sucked off, man, this must be my lucky day. Yeah. Starts getting sucked off. He's like, wait a minute. That should be a red flag. Them hands.
It's rape.
This is Savannah Ryan Williams, a transgendered woman, and she has asked Darian Bible if he wanted to have sex. Now, Savannah seems to be a prostitute with a long criminal history. For instance, at the time of her death, she was currently listed as a fugitive from justice on robbery charges. So on November 29th, she meets this guy, and this is what happens.
On November 29th, Minneapolis police responded to an early morning shots fired call near 4th Avenue South and Lake Street. Court documents say 25-year-old Demarion Kalon Bible admitted to shooting Williams in the head.
Now, the strange part about this whole scenario is the reasoning on on why Bible believes he had to shoot the victim. Listen to exactly what happened between the two.
He told police she approached him for a sexual encounter, but he began to feel, quote, suspicious after the act and shot and killed her. Bible confessed after police found surveillance video of him at the scene near the Lake Street light rail station.
Now, one source of a lot of confessions from criminals comes from jailhouse conversations. See, the state owns a jailhouse, and if you call into the jail, all your phone calls can be recorded. So a lot of confessions are obtained by the recordings of jailhouse phone calls. People like to confess on the phone for some reason. And that's exactly what this guy did. He confessed to his crimes over a jailhouse phone call.
Paperwork says while in jail, Bible told his dad he just murdered someone, and he felt sorry for killing the victim and knew he wasn't God, but he, quote, had to do it.
Now, the facts of this case seem to be pretty clear. Bible shot the victim because he was fooled into believing he was having sex with a woman, but it happened to be a man. So now there are three possible charges that Bible could be facing. He could be facing a voluntary manslaughter charge, a murder charge, or a...
Okay, we'll take a look at it. All right. Wow. Live testing. Oh, that's interesting. This idiot, what he says, why Jews are hated, is probably going to give the wrong. Jews are not hated. The hates.
That discussion, then I'll give you my reaction. Why do people hate the Jews? I just wrote that one. I just thought it'd be a good way to wrap it up and ask it.
The best historical answer that I know is something which doesn't really come from Christian theology, but still, I'll give you.
He's going to give a wrong answer. I mean, the right answer is people are jealous of the Jews. The Jews are very successful and people are jealous. That's my intuition. What is he going to say? There's no way he's going to say that. He's going to deny that the Jews are hated.
Three statements and try to connect them in a logical way. Statement number one, Jesus came to save all humans from our misery. Statement
Yeah, he's going nowhere. He's not answering the question.
number two, I'm still miserable. Statement number three, the Jews killed Jesus. How do you connect these three statements together in a logical way? You get anti-Semitism.
Right.
Yeah, it's got nothing to do with the reason. It's like the Jews are hated, period.
But add to that, I think that is one of the reasons that they think a lot of people think the Jews killed Jesus. Two,
Nothing to do with Jesus. I mean, the Arabs don't think Jews killed Jesus.
chosen people strikes a lot of people wrong. Just like, oh, you think you're chosen? Well, we'll see about that. And three, successful. Very successful.
Yeah, very successful. That's it. And that idiot doesn't know that. The Warari, whatever his idiot's name is. Marari, Garari, whatever.
No, but why do you think that there's anti-Semitism? Okay, but what about the young people now? What about this weird alliance between wokeism and jihadism?
That's going on. You've got like this many Jews on TikTok, which is the most important mechanism to transmit information among young people today. And you've got a vastly larger Muslim population. The algorithms are driving the hate, as you've all suggested. That's actually a big component of why it's growing right now.
So the answer is get more Jews on TikTok.
Well, thank you very much.
Well,
this is interesting. I have to say that I think all the reasons that they suggested don't provide a full picture. And I'll go through them with you. So let's think about it.
This guy's an idiot too. So he's like a religious Jew. So he's going to say, oh, it's because God, it's like something destined, God, destiny, God.
First thing they said was it's Christianity. Okay, so you say it's Christianity. Well, first of all, a lot of anti-Semitism has come from non-Christians as well. Hitler, the greatest anti-Semite of all, was not Christian. Now you could say, yes, well, he was raised in the backdrop of a Christian Europe, which had a history of anti-Semitism. Fine. The Islamic world is not Christian. There has been...
Come on, spit it out.
It has existed in other elements of exploring. But saying that it's all just about Jews, deicycling Jesus, it doesn't add up because also the Romans did it. It wasn't more because one person did something. If that was the case, then why don't they apply it to the Romans? No, it's that Jews forever are condemned. You give them for they know not what they do. To be chosen, but it's just to help spread God's light. It's certainly not about one is
help spread God's light. There you go. All right, idiot.
Story of a transgendered woman who tricked this man into having sex with her and then
denied that allegation, instead claiming the shooting was done in self-defense. The jury didn't buy that claim. At sentencing, Bible apologized for the shooting.
Now, the community wanted Bible to be charged with a hate crime, but prosecutors did because they didn't feel they had enough evidence to show that Bible shot the victim just because she was trans.
Hennepin County
extraterrestrial civilizations. Extraordinary evidence requires extraordinary funding. If we had invested $10 billion in the search for extraterrestrial civilizations, similar to the budget allocated to the Large Hadron Collider or the Webb Space Telescope, we might have already found our cosmic partners, and the cosmos might not have been as lonely and dark as it appears to us now. Over the past 70 years, we searched for looking for debris that bears no resemblance whatsoever to any sort of natural substance, or indeed any sort of substance that we are familiar with that occurs naturally within our solar system, but bears a great deal of resemblance to artificial substances. As we are about to see, the debris that was gathered by Dr. Loeb and his team could not possibly have come from a human point of origin. It came from outside, not only from outside our solar system, but from an entirely different solar system. So I'm going to be quoting extensively from Dr. Loeb's recent article, and also from a paper that was recently published, not only by him, but also by the other organizations around the world that were involved in the analysis of this amazing debris. The object in question is known as IM-1. And for those of you who are familiar with this story, I'm going to cover it rather briefly, and I'm going to link some videos that cover the topic a lot more comprehensively at the end of this video. So again, as I said, the object in question is known as IM-1, roughly about half a meter in size, very small, and it collided with Earth on January 8th, 2014. It was picked up by the U.S. Space Force, or at that time, the U.S. Air Force, which kept a very close eye on any objects that appear inside our atmosphere to make sure that they are not ballistic missiles on their way to strike a target inside the United States. The object was measured at a speed of 60 kilometers per second, which is faster than 95% of all the stars in our galaxy near the sun. But despite its high speed, it disintegrated in the lower atmosphere, where the air is dense, and long after the object should have been completely destroyed by the intense heat generated by an object moving that quickly through our atmosphere. This implied that it was tougher than all meteors that have ever been documented by NASA in the CNEOS catalog of meteor fireballs. This is why Dr. Avi Loeb found himself very interested in this object, because it didn't seem to be a conventional meteor, and given the fact that it was traveling at 60 kilometers per second, which is well above the speed necessary to escape from the solar system, it had to have originated from outside the solar system. Now, there have been a number of scientists and astronomers who tried to debunk this, saying that the object wasn't actually traveling this fast, it had been misidentified, but the US military has repeatedly stated that they are 99.99% certain that this object was traveling at the speed that was measured and came from an interesting...
I'm gonna get some gum. Mhm.
stellar point of origin. But it took the Galileo project and Avilov's research team a full year to plan an expedition to the fireball site of IM-1 in the Pacific Ocean. The U.S. Department of Defense provided the team with the exact location or the suspected location of the object off the coast of New Guinea, actually close to an island called Manus Island, and the team also surveyed a control area outside of this region to make sure that they were searching in the right area. If they found debris in both regions, both the control and the impact site, that would indicate that they didn't have the right site. So they were very thorough and had some pretty good equipment. They, of course, had a ship called the Silver Star, and they anchored a sled full of magnets and dragged it across the ocean floor in the survey region, and as I mentioned before, in a control region outside of that area. The survey was carried out between the dates of June 14th and June 28th of 2023, and the team collected 850 tiny spherules, less than a millimeter each in size. But in spite of the tiny size of these spherules, they were very significant because these are the types of spherules one would expect to find in the impact site of a meteor that has made its journey through the atmosphere and had its metallic components shattered and melted into these tiny little objects. But it was the composition of these objects that was found to be so incredibly unusual. But the initial analysis wasn't enough, and days after the team announced their initial findings, they already found themselves under attack by many members of the mainstream scientific community and media who claimed that they had found nothing more than mundane and ordinary human debris because it did seem to be so artificial and it could not have come from a meteor. Indeed, they didn't even think that IM-1 was an interstellar object at all, in spite of the conclusions of the U.S. military. But undaunted, this team turned over their materials to a team of scientists and chemists all over the world, and the analysis was carried out by a variety of state-of-the-art laboratory instruments to determine exactly what the composition of these spherules was and just how unusual were these objects. And by the way, the analysis was carried out by instruments like the X-ray fluorescence analyzer, the electron probe microanalyzer, and an inductive coupled plasma mass spectrometer. It takes a considerable amount of time to analyze materials completely and thoroughly to make sure that you're not making any mistakes, to make sure the debris hasn't been contaminated by anything in the laboratory or anything that was gathered during the survey, and also to try to identify any missing volatiles. In other words, chemicals that may have been present in the object before it passed through the atmosphere but were subsequently burned off. And the results were more bizarre than anyone ever suspected. 78% of the spherules showed up as being primitive. That is to say, they weren't all that different than materials that one would expect to find in a conventional meteor. However, 22% of the spherules, quite a few spherules, reflected a composition which was very different indeed. These spherules were classified as D subset spherules, and they showed an excess of beryllium, lanthanum, and uranium, up to 3 orders of magnitude relative to the solar system standard of these types of elements in meteors or any other object in the solar system. In other words, these spherules contained up to 1,000 times as much beryllium, lanthanum, and uranium as any object in the solar system that we have ever studied. Only artificial objects contain this much of these types of materials all in the same object. And oftentimes, you can find these types of materials present inside nuclear reactors. Beryllium is a substance used to control the intensity of nuclear reactions. And if you'll forgive me, I'm going to give you a quick lesson in nuclear power. What you're looking at right now is the core of a nuclear reactor, or an animated depiction of one, surrounded by beryllium rods. And these beryllium rods can reflect neutrons back into the core of the reactor in order to intensify the nuclear reaction. But the other side of the rods, if they are rotated, are coated with boron, which slows down the intensity of the reaction. So if you rotate the rods with the beryllium side facing the reaction, it makes the reaction much more intense, producing a lot more energy and a lot more heat. And if you turn the rods in the opposite direction with the boron coating side facing the reactor core, then it slows down the reaction and cools the process. So again, beryllium, incredibly useful inside nuclear reactors or reactors used for nuclear engines. And of course, uranium is something we can expect to find in nuclear reactors as well. And by the way, the footage that you're watching right now comes from a NASA and Department of Energy documentary covering the development of nuclear thermal engines from the 1950s to the early 1970s. And so 2 of the elements that were discovered in the spherules are absolutely critical to the proper functioning of nuclear thermal engines, or just about any other type of nuclear engine that makes use of fissile materials. Now, the lanthanum side of the equation is a little bit more complicated. You don't find that material as much inside nuclear reactors. But lanthanum alloys have a variety of commercial uses. For example, lanthanum nickel alloys are used to store hydrogen gas for use in hydrogen-powered vehicles. Lanthanum is also found in the anode of nickel metal hydride batteries used in hybrid cars. Rare earth compounds containing lanthanum are used extensively in carbon lighting applications, such as studio lighting and cinema projection. They increase the brightness and give an emission spectrum similar to sunlight. You see why Dr. Loeb has explored the possibility of these being artificial objects. Again, over 75% of the samples gathered appeared to be from an ordinary meteor, but it is the other 22% that is so unusual. It suggests a meteor that for some reason had a miniature nuclear reactor inside it, or some other advanced piece of technology that requires the use of beryllium and uranium impacted our planet in 2014. Now, it makes a great deal of sense for a spacecraft designed to survive the rigors of interstellar space for decades or perhaps even centuries to be built this way. If you take your more sensitive technology and sheath it inside a resilient meteoric object, it will be able to survive the intense radiation, micrometeoroids, and other hazards that might be encountered during a long interstellar journey, and even perhaps survive passage through an atmosphere. And indeed, it almost did. We're talking about an object that made it to the densest parts of our atmosphere without being destroyed, in spite of the fact that it was traveling much faster than most meteors that impact our atmosphere, and it was so small that it shouldn't have been able to survive that long. This suggests something that may have been designed rather than something that came about by random chance in a distant solar system. Then again, there are possibilities that these materials could have been created as the result of some sort of supernova explosion, could have been thrown off from a white dwarf. There are potential natural explanations. But what's more important is the fact that the vast majority of the debris has yet to be found. And it is for this reason that the Galileo project is going to be returning to this region of the Pacific Ocean off the coast of New Guinea to conduct a much more in-depth survey, and this time with a submersible, with cameras and other equipment designed to find the core of the object, which Dr. Loeb and his associates suspect probably survived atmospheric re-entry. And instead of examining a few hundred tiny spherules, you may instead be examining the core of the object to determine its true nature. And whatever is found in 2025, it is likely to throw the entire scientific community on its head. Thank you very much for watching. Please don't forget to like and subscribe. Also, please consider supporting this channel.
Mm-hmm. Oh my god, he lost his hand. That's like bionic.
My hands, like we always underestimate the importance of having fingers and the way that your hand help you in your daily activities. And when I mean daily activities, the fingers and this finger. So I could not grab things. So I struggled to carry things, and I used to use both of my improving. I was able to use it. However, after I think 6 weeks, once those are fully mummified, actually I'm using them to grab things such as, for example, my mobile, where I can use the the fingers, the mummified fingers, to grab items, and I can use them for basic activities. However, after the amputation, I will need to adjust using mainly this thumb without having the fingers. One of the questions I got was why we don't keep them. Actually, eventually, those may fall off after some time. However, I have a risk of infection, and also because of them being there and having the risk of infection, it may take very long time for them to fall, and I may cause myself further damage below. So amputation is required at this stage.
Oh, wow. Sorry to hear that.
What is it? Where does it come from? Unfortunately, if you ask YouTube these questions, you're going to get some wrong answers.
What is gravity?
Some very wrong answers. Namely, you're likely to come across an explanation which purports that time dilation is the cause of gravity. Indeed, almost as
How can time dilation cause gravity? Time dilation happens in special relativity. There's no gravity in special relativity, so that's ridiculous.
We call them prime numbers, but are those values universal?
Off rooms that
Until recently, David Benatar was a professor.
This video is brought to you by Brilliant. Click the link in the description to sign up for free and support this channel. There was a time when everything that happened was seen as random or a seeming miracle, sometimes attributed.
Hello guys, welcome to my YouTube channel. This is 100 Days of
You learned integration wrong. That's quite a claim, so let me clarify what we mean by it. Our claim is based on studies of former calculus students that analyzed what students
later.
It's like this is supposed to be me. What's the logic? Why would you put somebody who's not me? My God. I think it's him. It's him wearing a mask. I don't know who it is. Oh, you know what? It's actually a good idea. People will think it's me, so fine.
수능 대비 DNTM 마약 모의고사 나영 해설 강의를 맡게 된 수학 강사 주예지입니다. 만나서 반갑습니다. 자, 그럼 이제 주관식 27번으로 넘어가도록 할게요. 자, 그렇게 어려운 3a제곱 x 더하기 f' 제로가 된다. 자, 지금 이게 3차 함수. 요 그림 조금만 더 확대해서 그릴게요. 자, 이렇게 함수가 있는데 자, 너는 여기서 12를 가져야 되고 너는 여기서 마이너스 4를 가져야 돼 라는 얘기예요. 각각의 y값이. 그럼 여기서의 극대값과 극소값을 찾아야 되는 거죠. 아, 얘를 한 번 더 미분해야 되네. 자, 우리 이제 얘를 새로운 함수 gx라고 합시다. gx를 뺐을 때 취소가 될 수 있는지. 자, hx 꼴 한번 보도록 합시다. 얘는 절대값 x-a
Hey there, Mr. Terry.
Who is the greatest physicist of all time? There's a good chance you just thought of Isaac Newton or Albert Einstein, and deservedly. Newton is arguably the father of physics and calculus, and Einstein, well, his face is basically synonymous with the word scientist, not to mention relativity and everything else he did. I'd like to propose a slightly more specific question, the one in the title. Who is the greatest American physicist of all time? And by American, I mean born and bred in the United States.
Why?
I'll ask you to pause this video right here and leave your answer in the comments below. My answer to this question will probably surprise you, and by the title and thumbnail, you know it's not Richard Feynman. But by the end of this video, I think you'll agree with my pick, because from high school chemistry to vector calculus to thermodynamics, his influence is truly immense, from a conceptual level even down to the notation we use. In fact, by his own admission, this physicist bested Einstein, and yet most people know nothing about him. You've almost certainly heard his name, but probably didn't give it very much thought, and I made this video to change that. On February 11th, 1839, in the city of New Haven, Connecticut, Josiah Willard Gibbs Jr. was born. His father, of the same name, was an American linguist and theologian who served as a professor of sacred literature at Yale. A staunch abolitionist, Gibbs Sr. is most well known for his involvement in the famous Amistad case, in which African captives aboard the Spanish slave ship La Amistad mutinied around the coast of Cuba and tried to return to Africa.
Okay.
We passed our goal. Give me a high five. Boom. Thank you. I've had ME/CFS for 12 plus years. This gives me hope. That's what this is about.
Long COVID and ME/CFS have completely ruined Diana's life, and there's no treatment for it. So we shared a day in her life to raise money for a cure. 600,000 people have seen the live stream.
It was Diana's idea to do this stream, show everyone what a day in her life is.
Part of what we're doing now is raising money for the Open Medicine Foundation. They do clinical trials, which is really important to be doing that now to get drugs to patients really quickly.
Oh my God.
Not many people become as sick as Diana. She is exceptionally ill. That's the truth of it. It's terrible. A lot of patients become house and bedbound at some point in their illness. And just now with COVID, is funding starting to get pushed into these diseases. So we're really proud to just be contributing to the visibility of this. We passed our goal. Give me a high five. Boom.
You're early. Dinner's not ready.
Okay. Rachel and I will go play in her room.
Really?
I'm hungry. Go cook. All right, you little lump of clay. Rachel. What kid doesn't like new toys? Moron, that's who. Okay, look at the pretty colors. Now, what color is this?
Orange.
Yes, that is orange. What color is this? Okay, blocks going away. Bye-bye, blocks. Next time, reinforce the levees. Bad Corps of Army Engineers. Bad. Oh, what's this? Rings! Look at the rings. Now, the goal of this game is...
Oh my God.
To not kill you.
You're early. Dinner's not ready.
Okay.
Things almost went super wrong on Mount Everest because of this climber.
Is that a butane tank that's just hanging out in the open?
Oh, man!
The minibot is incredible!
Then you have your multibot that comes
Oh! Wow, that is a retro butane tank!
That was like thunder!
In the
Whoa!
bottom
Wow, there it is!
Oh my
There
God! Puncturing the top plate and hitting that battery! Impact Lab is your winner.
I want to see that explosion from every angle.
I think with that boom, it's going to stick with me this week. Is that a beaut?
One night, as you do,
Let's listen to some incredible facts about eagles.
The sterile field is the cleanest part of the operating room. It's where we keep all the instruments, and you don't want to touch it unless you're gowned and gloved, or if the case is canceled and you got to clean up. The sterile field is...
This tool can open every safe, but not as quickly as in the movies. It works by cycling through every possible combination until the door opens. But it's not the device that knows when to stop. It's the mechanics of the lock that stops the tool. As a safe can have up to 800,000 different combinations, it can take up to 6 days to open. This tool can open every safe, but not as quickly.
All the same weight? Within a quarter gram. You have a scale? Take your pick. Forgot how to count? You get 5. Don Hector gets 6. He's expecting 6, and that's what I'm gonna bring.
He's trying to take 6. We only want 5. He's pushing it.
Give it to him. Sure. Give it to him. All the same weight?
You're early. Dinner's not ready.
After the hurricane, cell service was out for...
Every night before bed, her grandma checks her gas stove with a flashlight just to make sure everything is turned off. And when she catches her granddaughter recording her doing this, her reaction is so wholesome. Every night before...
The customer said her dryer was making a loud noise.
Have you ever wondered why we don't ride zebras?
What's going on? What? You just take off and make it at 90? No. Absolutely not? No, absolutely not. There's a red bike being 230 now. That was definitely not me. All right. Oh, man. What's going on?
So, River just called us.
Yeah.
Said a red Ducati with a guy wearing pants like that just ran.
Okay, that was not me.
Where are you coming from?
I just came from Westlake.
That's exactly where he was called.
Okay, that was not me.
Were you driving aggressively fast on 90?
No. I mean, I'm going faster than the speed of traffic. I'm not going that fast.
All right, they clocked a red Ducati at 143 miles an hour, and they chased it, and they said it got off on 117. And I saw you on 117. You know what I mean? Are you willing to give me your driver's license?
Yeah, I can give you anything you need.
All right, let's get the license. This is your plate. Appreciate you being cool about it. It's
yeah,
just,
no.
There's a lot of variables that are pointing to this. I mean, you know what I mean?
It seems a little coincidental, but... What's going on?
If your science class taught you that lightning never strikes the same place twice, you might need a refund. The Empire State Building gets zapped by lightning around.
This tool can open every...
Hey,
as promised.
nice board. Where's the rest?
The rest. This is all.
I asked for 50 computers. That's keyboards, cases, monitors, and power included, not just boards.
Just boards. Excuse me, just boards. These are state of the art. The logic boards alone are, nobody's making anything like this. How dare you?
I think what my colleague is saying is that you're not seeing the possibilities here. That is indeed one unbelievably kick-ass computer.
Not to the consumer.
Well, then maybe your consumer should start.
Listen, boys, you sold me on a home computer. That's a keyboard and monitor. This is a board. Now, I'm sure this makes a very capable starter kit, but the everyday person, the kind of person that's not an engineer or in a computer club like you, they're not going to know what the hell this is. The average Joe doesn't want to build their own computer. They just want to buy it, plug it in, and have it work.
Hey, as promised.
Nice
Wow,
board.
genius. You listen to the customer. That's the trick.
These scientists just won a shared Nobel Prize for solving one of the most important issues of modern science.
Your muscles have a certain memory.
This little penguin jumped on a tour boat, just nearly escaping a seal attack. So this tour group, who was on an expedition in Antarctica, decided to take the little penguin and find his family. And luckily, they found him on a nearby iceberg. They parked it as close as they could so he could jump off and run back to his home.
Recently, we got an order for a cake shaped like a cat. It was for a birthday girl whose parents wanted to give her a real gray kitten as a gift. We made 2 cakes and stacked them on top of each other, trimmed part of the top cake to make it look like a semi-sphere, and covered the cake with tasty chocolate ganache instead of fondant because it's much tastier. To shape the kitten's head, we used a flexible acetate sheet. Unlike a regular spatula, it easily bends and works great for smoothing round figures. For the kitten's ears, paws, hat, and face, we used modeling chocolate since it holds its shape better than fondant. And
Damn it! I'm sorry.
I'm sorry.
Who the hell walks around with an open urine sample?
I'm sorry. I didn't.
You think that was a bit of an overreaction?
Well, he peed on me. I'm not into that.
It's apple juice. Now go find that guy and apologize. One more patient complaint and you're looking at a suspension.
I forgive you for ruining my jacket. Look, you seem like a regular kind of guy. Not the type to get another regular guy into trouble, all right? $20 cash if you'll stop crying. Forgive me, yell at me. Just give me something I can work with, okay?
Game's over. You two make nice.
Get a wheelchair. Can't leave this guy into the ER.
What happened?
Right pupil's blown.
Holy, you gave the guy a stroke?
Damn! How do you know the exhaust is modified?
That's not stock, number one.
We say the universe began 13.8 billion.
A total of $250.
Can that be deferred a little bit? I'm just in a bit of a financial situation, which is why.
How much can you pay today?
I have not.
There's this mystery man I've been chasing.
He's on EPO. Your anemia is caused by pure red cell aplasia. This is gonna hurt. We gotta talk.
What the hell are you doing?
You'll be fine. PRCA comes in two varieties, chronic and acute. Since it came on fast, you have the acute version.
He doesn't have cancer.
Is the good news. The bad news is pants are on fire. Acute PRCA is caused by drugs, most commonly EPO. Ready and action.
I haven't used EPO.
Okay, remember this guy's accusing you of cheating.
I haven't used that stuff.
Oh, what? I believe you.
Read that. He doesn't do EPO.
Did she handle any of your injections?
You think I'm giving it to him?
Hey, you know what we can test for? Phone calls. Okay.
Oh my god, she gave him drugs. She
Your
drugged
anemia.
him. Oh my god.
This is going to blow your mind. What if I told you there might be endless versions of you living in different...
Yeah, okay.
During the hurricane, this girl noticed a puppy in the distance struggling.
Let me just start beating you a little bit to make you feel at home. We know each other, right?
These parents found out their baby had super bad vision, saying the doctor was speechless on how bad it was. But this was the moment the doctor put glasses on him.
Did you know the Hubble Space Telescope has been...
Not how I'm used to seeing you in here, Mr. McGill.
Not how I'd like to be seen.
You had quite the day yesterday. You've been accused of fourth-degree felony breaking and entering, which carries a maximum sentence of 18 months. We've also got petty misdemeanor assault, maximum 6 months jail time, plus criminal damage to property, also misdemeanor with a maximum sentence of 6 months. Victim is your brother, Charles. Seriously? I assume you're prepared to enter a plea at this time?
I wish to enter a plea of not guilty.
Have you secured counsel?
Yes, Your Honor. Kim Wexler. I'll be representing Mr. McGill in this matter.
Let's enter Ms. Wexler as the attorney of record.
Your Honor, if I may, I'll be representing myself.
Your Honor, may I have a moment to speak with my client?
Sounds like he's not your client. Mr. McGill, would you like to take a moment to discuss this with your potential counsel?
Oh, Your Honor, I'm all set. I'm going to represent myself.
Your Honor.
Not your client, Ms. Wexler. Not how I'm used to seeing you in here, Mr. McGill.
Not how I'd like to be seen.
You had quite...
Let me show you something I find completely magical. Behind this piece of glass, there appears to be a three-dimensional scene. You can move around your head and you see the light play off of the objects in different ways. For example, that glass Klein bottle in the front warps what's behind it. But it's an illusion. In reality, all that's there is an empty table and a diverging laser beam shining on the glass. It's hard to capture in a video how surreal this feels in person, because despite there being nothing behind that glass, every visual cue available is screaming to your brain that something really is there. One of my favorite versions of this is a recording taken of a microscope. Again, it gives this illusion of a three-dimensional object stored on a two-dimensional piece of film. And it's a little tricky to get this right, but if you put your eye at just the right point in space, you can look down the barrel of the microscope and see what it's imaging, in this case, a little microchip. Let me show you something I find completely magical.
You want out. Just talk. Be honest. Try to work with people. Try to deal with people.
Okay.
I don't know if that's appropriate, but there it goes.
Well, I shouldn't be telling this secret, but I have no secrets, so here we go. Poached salmon.
Our customer wanted a tiny little...
Your Honor, I'm afraid it's impossible for my client to plead when there's no offense alleged.
Nice try. But the offense is clearly alleged. Sunbathing topless on a public beach, despite repeated past warnings.
Yeah, but according to the police report, the officer arrived and found Ms. Wagstaff in the water up to her neck, and there's no record of any complaint prior to that moment.
So?
So, by ordering her out of the water, the officer created the very offense with which my client is charged.
You're kidding me, right? First of all, that's a question for a jury.
If Your Honor really thinks that's the best use of judicial resources.
Do you have a witness who could testify that they were offended by Miss Wagstaff before the officer ordered her out of the water?
Not at the moment, Your Honor.
Do you know what this is? It's my docket for today. Miss Wagstaff, keep your damn top on from now on. Charge dismissed.
Your Honor, I'm afraid it's impossible.
Scientists have now basically cured...
Your Honor...
So that's sexual discrimination. That's ridiculous. That's like so illegal.
But really, nobody makes the case against Lion Kamala Harris better than Kamala herself. So Kamala just said that she can't think of one thing she'd do differently than crooked Joe Biden, right?
Well, as expected, Kamala Harris's comments on The View are coming back to haunt her as Donald Trump exploits a statement that she made about how she would do nothing differently than Joe Biden should she get elected into office as president of the United States. In fact, here's a reminder of what she said.
If anything, would you have done something differently than President Biden during the past 4 years? There is not a thing that comes to mind in terms of, and I've been a part of most of the decisions that have had impact.
Now, Republicans are planning to use that clip in a massive ad campaign in the hopes of tying Kamala Harris to all of Biden's leadership and issues. Trump also played a clip, or the clip, at a rally in Pennsylvania yesterday for the crowds to hear in real time. One Trump ally told Axios, quote, "Expect to see this clip every single time you turn on the television between now and November 5th. And this is something that we learned about. The one thing that Kamala Harris is polling well on is that she is seen as a change candidate. That is working to her favor. And so when she ties herself to Joe Biden and says, no, I would do nothing differently, well, that's not going to bode well for her because she's signaling that it's going to be a continuation of this administration, which, whether you like it or not, does not have a great approval rating and could hurt her in the elections.
Yeah, look, anytime we try to warn them, they say, oh, you like Trump. No, we're trying to beat Trump.
Wow, this got 1 million views. People are saying that it's American communism. I find the concept to be interesting. It's basically when you allow people to be free and they decide to have communism anyway. It's called a homeowner association, where every single house needs to look the same. Every single fence needs to be painted with the same colors. Everyone needs to behave the same.
Oh, getting zapped?
To avoid getting shocked by your car while getting out of it on a cold, dry day, touch the outside of the door frame as you get out. That allows the static charge caused by sliding across the seat to flow into the metal frame through your hand, so it never has a chance to build up and shock you. It even works if you're riding shotgun. Sorry.
Here's a few simple life hacks for dropping nuclear bombs in your F-111 fighter bomber. Assumes you First, have one. don't forget to enter the nuclear codes. Then
Just press that button and it's goodbye. I can see that you're worried, and I just want to assure you, I am not human, and I cannot feel pain.
Thank you. That helps.
However, I should warn you, I am programmed with a fail-safe measure. As you approach the kill switch, I will begin to beg for my life.
Okay, here we go.
Chidi, no! Chidi, please, don't hurt me. I don't want to die, please.
Why did no one tell me that the world was going through a banana pandemic and that bananas were at risk of going extinct? To make matters worse, this isn't even the first time that it's happened. In the 1950s, the Fusarium wilt of banana pathogens wiped out commercial banana crops, causing the Big Mike banana to go completely extinct. If you've ever tried banana flavored anything and wondered why it doesn't really taste like banana, it's because it's modeled after the Big Mike banana, which was the type of banana that everyone ate up until the 1950s. This disease is back, and it's moving with stealth transmission, spreading between bananas before symptoms even start to show. The virus made its comeback in the 1990s, but over the past decade, it's been accelerating rapidly, spreading from Asia to Australia, the Middle East.
When this guy was releasing this fish, he had just caught back into its lake. I don't think its fishy friends appreciated its absence. And when the guy left his hand lingering near the pond for too long, he paid the price.
Swim off, you beautiful, beautiful.
This is a camouflage system that uses mirrors.
Only sharp awareness and vigilance. Say, welcome to pod 3 of...
Oh, the stitches are healing nicely. There's no sign of infection.
Whoa. Sorry, just need her for a tiny moment. Small favor. Pills.
Who's the wit? Doctor. Don't worry, I'll be firing him soon. Wait in my office.
Incision looks just big enough for a chest tube. A collapsed lung? Someone mistake you for pinata?
Delightful. Usually we just get the elf jokes this time of year.
No one trauma. Negative PPD. What flavored dwarfs are you guys?
My daughter and I both have cartilage hair hypoplasia. Think you can make a pun out of that?
Yes, but I don't want to be insensitive. She's got a bit of a short fuse, isn't she?
It's a bleb. Wait in my office.
Bleb's not a diagnosis. It's innovation.
We'll schedule an MRI to make sure, but a certain number of these cases are idiopathic.
Let me translate that into talking for you guys. It means Dr. Cuddy's got no idea why your daughter's lung suddenly popped like a balloon.
You think you do?
Give me her chart and my pills.
Oh, the stitches are healing nicely.
Just press that button and it's...
Luther, what's up?
What's up? What's up is you gave my daughter gonorrhea, you little shit stain. That's what's up.
I did? How do you say sorry to a girl you gave a disease that could kill her? Flowers? But you gave a girl what? Gonorrhea. Ah, shit. Get in.
Why did no one tell me that the world...
Hey, want to sign up for a Visa card?
No, thanks.
$5,000. And that's just antibody. That's the surgery.
What would happen if we covered our CPU with a gold film instead of using thermal paste? Because after all, gold conducts heat like 30 times.
Were the Japanese kamikaze pilots welded shut into their planes to ensure that they could not get out? This is a popular myth.
I made this lock to be pick-proof. With
people in a shop, if you play French music, you sell twice as much French wine. If you play German music, sales of German wine go up. And yet most of the people leaving the
Bend the paperclip into a straight line, then create a small hook at one end. Carefully insert the hooked end into the keyhole of the handcuffs. Feel around inside for the locking mechanism. It's a small bar that holds the cuffs shut. Once you've located it, gently push the hook upwards to lift the locking bar. As you do this, apply...
What's your secret weakness? I don't think I have one.
What? No, come on, you have to have.
This is an unpickable lock from Godridge. It's...
Man, I'm done. I'm toast. This is my license.
What's up?
Yeah, I already know.
Where do you live?
Millis?
Millis?
Yeah.
Okay, you been coming around here?
I just stopped at his house.
Okay.
I haven't been.
I'm going to take a break.